YouTube or on Slack. And now this conference would not be possible without the work of the local planning committee. So let's take a moment to thank those people for their efforts. So from, yes, absolutely. So I particularly want to call out from Princeton, Kate Lynch, absolute rock star. Esme Coles, also absolute rock star in the back of the room. Also, Carrie Gordon. Yay, Carrie. And Sean Warren. Yay, Sean. So a few other reminders. There's a quiet room available on the lower level. It's got carpet, it has dimmable lights. That room is friend 004. If you're looking to refill your water bottle, there's a refill station. It's at the back of the end of the hallway, up here to the right. Bathrooms, there's bathrooms in the upper atrium, down the hallway to the left of the registration desk on the left. There's additional bathrooms, including a gender-neutral restroom on the lower level of Friends, on your right as you come down the stairs. Princeton does have the following policy. All members of the campus community and visitors are welcome to use the bathrooms and changing rooms that reflect their gender identity and/or gender expression. All right, lightning talk time. Very exciting. There is just one lightning talk slot available, but it is not too late to sign up for that. We also had a cancellation in our first block of talks, so we have a little extra time, potentially, for lightning talks. Lightning talks will have slides, but of course, again, not doing presenter note setup. Lightning talks must be presented from the podium computer. So you'll be up here. Okay, looks like we are ready to get started. We're ready for lightning talks. So the very first lightning talk is the buddy system from Ann Archivist. Yay!
Good afternoon. Hey, y'all learned something in my time away. So some of you may know that I left libraries for a little bit and worked for a startup. So this is Sasha. Sasha is the best boss I've ever had. I got to work for him for about a year and a half. Well, about a year, and I learned a whole lot from him. I learned about management, I learned technical topics, but really the most important thing I ever learned from him is about the buddy system. So this will probably not be a surprise to some of you. The buddy system is a way to eliminate surprise. It is a way to ensure you are not lost, you are not stuck, you are not adrift. It is not pair programming, extreme programming, any number of other orthodox methods. It does not mandate a specific set of techniques. And the reason why I bring this up specifically is because I just sort of thought of this because of some of the things that Kate brought up in her presentation this morning, is that pair programming can be really rough for people who are neurodivergent. And this, sort of this reframing of some of those same techniques I found really useful as a manager in a startup. So really the baseline is you want to talk to at least one person before you start working on a task. They are your buddy. When I worked at the startup, what we actually did is we indicate who the buddy was in our task tracking system. And that way the two of you had sufficient context on the problem. It may still be that you're the only person who's actually writing code. But the idea is they should have enough context. They should not be surprised. The example that I like to sort of give in these situations is, imagine you're building a React application and you have a very well-defined feature, you have like a product manager and a designer who's giving you great specs, and you come across a team member who, you're buddying with them on this, and suddenly they've refactored your React application to use Angular. What do? You tell on them? Did you have a common agreement about the task? And you start to grill them on this. They say, oh, well, the React ecosystem was broken for these ways, and blah, 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 blah. It doesn't matter. I think the thing is we often lose sight of the tasks that we're working on, and that's why this is particularly important. The other thing is people are out. We are still, for better or for worse, in an active pandemic. So people get sick, people have emergencies. And so ideally, this is to help you be in a situation where someone else can pick up your work. You provide enough context on that. Is that it? That's weird. Oh, maybe that's all I have. Anyway, on that note, I'm going to wrap up in just a second. But I think the thing that's really, really useful is just thinking about think of it as a conversation. It does not need to be a face-to-face conversation. You don't need to use a shared workstation. You don't even need to have Zoom. But it's just figuring out whatever method actually works for you. The other thing is don't lick the cookie, and you can ask me about that. Thank you.
Fantastic. All right, our next lightning talk, Li Yang, evaluating an AI-based recommendation engine.
Oh, where's the mouse? Here we go. Hello. Oh. Hello, guys. So my name is Li Yang Q. I'm the usability librarian at Lehigh University. This is my first Code4Lib, as well as my first lightning talk. Thank you, guys. So yeah, just like many institutions, Lehigh use an existing similar item recommendation system. For us, we use Solar more like this functionality. However, took inspiration from last year's workshop about building a recommendation agent using AI. We built our own little AI that can help us to recommend books to our patrons using a sentence transformer. That raises a natural question. When is an AI solution better than an algorithm that we already use and understand? And if so, what does better actually mean? And how do we actually measure it? To better measure it, per se, we built a test prototype on our test server. Instead of just one similar item, the book item page will show 4 similar item recommendations. Each list would use a different sorting method with a dedicated symbol. For this test, we compare between the original, Solar more like this functionality, AI generated with title only, AI generated with title and summary, and AI generated with title and table of content. So this is the 4 lists that user will see, or the test participant will see. So to best capture the patron preference at a larger scale rather than a one-on-one conversation, we set up a testing table at the front lobby of our FM library, which is our busy library with a lot of student traffic. For tests, students can freely approach the test table and do the test voluntarily. I will ask the participant to search a book using a keyword that they're currently learning about or interested in to represent something that they are actually going to search about. Participant went through the 4 lists that you saw before and vote their favorite on the tiny little board right next to me over there. To reduce bias as much as we can, the test is strictly double-blind, meaning that I have no idea which sorting method represents which symbol, so does the participant. This is the setup of our first day with big smiley face of myself, looking out there, having no idea the Pennsylvania coldness he's gonna endure at the busy front library. Did I say that out loud? Oh, sorry. Anyway, so we conduct the test for 4 different days during the winter semester. Here's the evolution of the test going on. With total, we have 71 votes from our student patrons. And here's the vote distribution. We have a clear leader and a somewhat distant second, and then 2 other things that just left behind. Anyone want to take an educated guess of which one is which? No? You guys are shy. So it's looking like this. Original is actually the first, with AI and title and summary being the distant second. Surprising? Maybe. But with the clear leaders, it is still unclear which one is better. To narrow this down, we do this test again and modify our prototype to do a more head-to-head style with the original and AI-generated title and summary. So we repeat our test for 2 different days during spring semester, again with the voting evolution over here with a total of 30 votes from our student patrons. And the final vote distribution looked like this, an almost 2-to-1 lead with one of the sorting method. Anyone want to take an educated guess again about it? Solar? Surprise! Again. So with that, AI generated with title and summary method is better, right? We should all switch to the AI one. The old one should left in the ditch. Yes and no, I would say. First of all, the default more like this use call number and topic beside title, both of them are both using, compared to the summary used by AI. And if you look at the contextual information on there, summary does offer more contextual information to make algorithm better at sorting it, compared to just topic call number. So, but summary isn't sanitized information. It's directly provided by our vendors compared to call number and topic. So it isn't a technically speaking apple-to-apple comparison. Our next step will probably involve modifying the more like this or AI to make it more equal footing, taking same weighting parameter to do the test again. But for now, you can say the AI has the edge. One last thing before I leave. I know I'm taking a lot of you guys' time. If you forget everything I said before, one thing I would like you to take away is that go and seek your patrons' feedback. This is the final day of my setup. You can see this is a board that I purchased for myself, a table, a chair, some candies, and a printout. That's all I did for collecting 6 days of data with over 100 patrons. You can do that too. Your patrons right outside your office door. They're out there. Our patron approached this station with nothing but genuine interest and passion about helping their library for better. If you have a new service, new website, new change, anything, just to prove something you don't know or disprove something you already know, go out there, seek it. Nothing fancy, just this. And with that, that's everything I have. If you have anything about the testing itself, reach to me. If you have anything about deployment, technology, how they actually work, reach out to my wonderful colleague, Matt Maccabee, who is far more popular in this round of work. So yeah, hope you guys enjoyed the Code4Lib. I have been so far. Thank you guys so much.
Thank you, Leo. That was wonderful. All right, next up we have Jonathan with Bob and Turnstile.
On a keyboard that isn't yours isn't as fast. Who knew? So, I'm Jonathan Rockine from the Science History Institute. I have permission to, oh no! I'm going to try to play you a video and it's not going to work. We'll deal with that when we get there. Who knew you need special permission to play videos? So, our bot's giving your website trouble. It's not just you. I was surprised even the operator of LWN.net, which is a newsletter about Linux, mentioned his site was having trouble. Everyone is having trouble with bots hitting on their websites. Our faceted searches provide a near infinite space where you can click on like every combination of facets that amplifies the problem. Most of us are having the problem. It's gotten really bad over the past year or so. Many people suspect, I was going to time myself, but I didn't. You're going to give me things? Okay. Many people suspect it's a lot of bots trying to train AI, but we don't really know. There is a bots channel on the Code4Lib Slack, and I went there to talk about it. There's other people there, and they confirmed, yeah, especially those of us with faceted search, that's what's getting hit, like bots trying every possible combination of every facet. They also said that people have been trying to block IP ranges, but the IP ranges vary a lot and can change. They're not all from China. Some people reported they can be very distributed, the IP addresses. There can be thousands of unique IPs, each making only a few requests. And somebody even said they tried scaling up their resources, and the bot traffic just scaled up too. So looking for a solution, I needed something. I have a very tiny team. I don't want to be constantly looking at my logs and trying to block, playing that pop-up game. What's that game called? The hammer and the moles? Whack-a-mole. So Cloudflare Turnstile is a free product from Cloudflare that you may have seen. It looks kind of like this. Sometimes it gives you a checkbox, sometimes it does not, and just passes. Cloudflare Turnstile is really intended for forms. It's its main use case. But I started thinking, gee, can I use it to protect get paths instead? And John Quarrel at Lehigh University on the bots channel said, oh yeah, I've done that, and I wrote it up in a great blog article, and he was also kindly talked to me and gave me some of the parameters so I could start from what he had done and not have to invent it from scratch, which was great. One of the benefits of doing this, you can also protect your whole website with Cloudflare. But one of the benefits of using this Turnstile tool is do not have to point your DNS to Cloudflare, do not have to send all of your traffic through Cloudflare or show them all your traffic. You have control of exactly when, how, and where you're going to present this little bot checkbox. And it is free. And the bots are probably always trying to get past it, and Cloudflare is fighting them, and it's free. I don't have to be constantly tweaking it. I'm going to let Cloudflare do that. It does mean that cookies in JavaScript are required to get past the bot challenge, just because of the way it works. So the way I've implemented it is I only protected search results and downloads, because that's what was giving me trouble, that infinite space of facets, and my downloads, because they're hosted on AWS, so I was paying bandwidth for them. It was a problem that bots wanted to, we also make our original TIFFs, 200 meg TIFFs available, so that bots wanted to download 30,000 200 meg TIFFs 18,000 times. That gets expensive. It redirects to it gives you 2 free searches before it challenges you, because I'm really trying not to get in the way of real traffic. I'm not trying to stop AI. I'm not trying to stop bots. We're a library. We want to make our stuff available. The problem was the resources, not the use. So I'm trying to keep this out of the way of people. So you get 2 searches before the bot challenge, if you just happen to get there, to hopefully realize, this is an interesting website, not give you the bot challenge right away to scare you. I cannot play a video, so I'll try to give you the live demo. What kind of a computer doesn't let you... What kind of a computer doesn't let you play videos? Typing is taking up valuable lightning talk time. What? Misspell. You don't realize how fast you can type. Depends on being familiar with the keyboard. That's not it. Valuable, .org, not .com. That's fine. We're almost done. This is the last important part. So we're going to do 1 search. Hopefully this IP address is unique. We got 1 free search. Let's do 2 free searches. It happened on the 2nd search. Watch carefully. You might miss it. This time it gave me a checkbox. Usually it doesn't. I checked the checkbox. I'm back to my search. And now I can do as many searches as I want. I can keep doing as many searches, and it will let me... It's stored a cookie that's given me this pass that's good for 24 hours. So when I come back in 24 hours, it'll give me another 2 free searches. I think that was basically all is that all my time too? Oh, great. Let's see what else there was. That's my 30 seconds. That's it. I would love to. Yeah, I thought doing it was more. Oh, no, yeah, we did skip a slide. There is various implementations. So I did this in Rails, and there is a Rails gem you can use with any Rails app. John Quarrel has a plugin for Drupal. John Quarrel also has traffic middleware for the traffic reverse proxy. It's also a feature built into Viewfind. I would love to talk about implementation, but I thought the most interesting thing was just how it works and that it works, and it's a free service. There's a bunch of implementations. The API from Turnstile is actually really easy, but using it in this sort of unusual way where it's not protecting a form is a little bit, just to get it right. So there are a bunch of implementations. Find me and talk to me. I would love to talk to you about this or anything else. Thanks.
Phenomenal job from Jonathan. Live demo, perfect timing, absolutely amazing. All right, next up, we've got Matt Nyoff, permanent scaffolding.
I took some inspiration from our keynote today, which is one of the best keynotes I've ever seen, honestly. And I'm stealing the scaffolding term, which I've never heard in this context before, to talk about a project we worked on at Minatex, which is a library support organization in Minnesota. We are housed at the University of Minnesota. And I'm going to talk about how we've done some work with resource sharing to build on systems that we are obliged to work with and we need to do better. So we have a problem. Minatex is a resource sharing partner on 6 different library platforms. Kind of as a lender of last resort, we become sort of a, item list broker. We don't own a collection. We are housed at the University of Minnesota and we make extensive use of their collections for lending. But we process between 250 and 350,000 interlibrary loan requests a year. Previously, every request would come into our office and be printed out on a piece of paper, and then staff would do the manual work of identifying who owns this. Does the university own this? Do our Wisconsin partners own this? There's also this problem of a pandemic that was coming down the road. We didn't know about it then, but it came in really handy. So here are some people doing work, just stacks. Every system was a different color. It was a different format. You're having to manually file all of these. These are requests that were made. When the item comes in, we match the paperwork and we ship it out. So our solution, I am now calling permanent scaffolding. We have an application we call Mira. It's a request management system where we extract request information from each system and they can be sorted into queues. I've had to cannibalize. This is the fastest presentation I've ever put together. So this is from an old, out-of-date presentation I gave a long time ago. But basically, I want all your data. We use APIs where we can to get request data. We do work in our system, and then when we're ready to either fill the request or say we can't find it, then we go back into the system via API or manually to do that. So this was an old one, VDX. This is for our public library system. We now use Project Reshare for that. That is now an API. WisCat is Wisconsin. I believe it's an agent system. For those systems, we are literally getting PDFs, and we are scraping them for a label, title, and then the next text is our title. So it's a little messy. Some systems, we were able to do Excel exporting from Iliad and get that into our system. Aleph now Alma does have an API, WorldShare has an API, and we have a web form if you're a public library and or a little K-12 school and want a request from us. This is kind of our process. We get requests in, we identify the lenders, we retrieve it from campus, we create a referral. That's where we're the borrower. It comes in, and we'll either fill this electronically or physically. But the other thing I took away from that really inspired me is we built this with our I call operational users. I love these new words. I had the advantage of doing this work before I moved into IT. I got a computer science degree while working there. Oops. And when I threatened to leave, they say, hey, how would you like to try IT? So I did that. In my undergrad, I was given The Design of Everyday Things, pretty common book. Also this article, Apprenticing with the Customer by Hugh Beyer and Karen Holtzblatt. I hope I spelled that correctly. We're really inspiring that we built our software by working with our users. And building a system that facilitated their needs was really important to us. And if you had asked any of them, there's no way we could have got away from paper requests when this started. But 2019, 2020 came around, and we were able to continue working remotely. And I honestly have no idea what we would have done if that was not the case. Pokemon was called for. Charmander's my favorite. If you are doing anything like this, we're a little 5-person team. I've kind of been developing this app mostly by myself. I have a partner in crime now who I'm thankful for. If you're doing this, please contact me. I don't know anybody else who kind of does this in resource sharing that says, hey, here's your platform, whether it's Alma, whether it's WorldShare. I want to take that data out and do my own thing with it in terms of request place. Please let me know. I'd love to have more colleagues. This is also my first Code4Lib, so this has been very refreshing. So, thank you. That's it.
Thanks, Matt. And extra credit for anyone who does a lightning talk at their first conference. Awesome. Okay, up next, Jason Griffey with Standards Need You.
Get this up. Hello, all. How's everyone? Boom. Excellent. Cool. All right. Hey, I'm going to start a timer because guess what? I got one on my wrist. There we go. All right, cool. So I'm Jason Griffey. I am a librarian and a technologist, but right now I work for NISO. And given the number of times this morning I have heard who, I decided I was going to introduce us to you who don't know. How many people have no idea what NISO is? Yeah, excellent, cool. So we are the National Information Standards Organization. What the hell does that mean? That means that we are the standards organization for North America relating to library and information standards. You've got ISO, big thing, Switzerland. You've got ANSI, big thing, America. They do all of the American standards. We do the library standards, the scholarly standards, the standards that relate to sharing of information. We create them, we publish them, we share them with you. How many times have Mark been said this morning? That's ours. ANSI NISO standard Z39.2 1971 is the first one. It was been revised obviously since that, but that is a standard that we helped create. How many people in here work with journals and or electronic resources? All right, you probably have heard of the credit standard. ANSI NISO Z38 140 2022 credit is also our standard. Dublin Core, our standard. And even if you don't do any of that stuff, ANSI NISO Z3840.48 1992 revision 2019, the permanence of paper for publication and documents in library and archives, make sure that your books stay where they are and don't rot. So we also do that. Anything having to do with standardization of information flows is things that we work on. And I am currently the director of strategic initiatives, which means I go out and look for new shit to do. What do we need to do that is coming up in the future? As part of that, we run a conference where we ask people to tell us what the new stuff is. And I'm going to spend the next 2 minutes and 41 seconds telling you what the new things are that we are interested in doing that we would like your help with. How's that? So these are like 7 ideas that we were presented with that may become projects, working groups, standards, okay? So I'm just gonna run through them and let you take a look. 1, develop a standard for using AI tools for research integrity checks and peer review process. Scholars want this, publishers want this, vendors want this. What does this sort of standard need to do? It answers how should the peer review process identify and flag academic work that's been unethically produced or manipulated by AI? You need standards for how that works. Develop a standard or best practice for using AI tools to augment metadata. We've already had 1 or 2 talks about that today. Enhancing discoverability while also ensuring consistency and interoperability. Well, how accurate is that AI? Is a human in the box necessary? We need best practices around this so everyone does it the same way, right? Establish a core set of metadata fields and a schema that reduces the cost of collection and analysis of usage data for books and everything else, a common usage standard for electronic resources across the board. That is a thing that people don't have. That doesn't exist. You have to mung everything together, right? In order to get usage stats out of your systems. We would love to have a standard metadata that did that for you. Develop interoperable metadata that accurately conveys accessibility of platforms and tools so that when libraries go to purchase a platform, they can look at what the accessibility level of that platform is before having to spend money on it. Imagine that. So descriptive accessibility metadata for vendor platforms. Vendors have asked us for this. They want it. So like, let's develop it. Develop a recommended practice for recommending indigenous knowledge in published materials and archives. The thing that we've talked about for the last couple of years at our conference. We have had repeated questions about representing indigenous knowledge in systems that are not built for those things, right? Like we have hierarchies and it's not built for representing lots and lots of different kinds of indigenous knowledge. So this is a thing that we need new standards for. We need new ways of representing that if we're going to do it, to not do it a disservice when it's entered into our systems. And then finally, federated authentication is an area that I work on a lot. Currently, we're working to get demand and usage up of the REFED's anonymous and pseudonymous entity categories in places where SPs and IDPs aren't kind of talking to each other properly, so that we can increase patron privacy and make for less data sharing between the library and the vendor, which I am all for. So we do a lot of stuff, and we would love for all of you to come help us. This is me. Drop me a line if any of this sounded interesting. Thanks.
Awesome. Okay, next up, bot strip min out site, Daniel Sanford.
Yeah, that's my terrible handwriting. That strip mined our site. So, hi, my name's Daniel Sanford. I'm with Hosting Solutions and Library Consulting. We're a nonprofit that works with the state of Pennsylvania to provide electronic resources for a lot of different organizations, including a digital asset system for people to upload archival data and share it with everyone, which is great. We want to do that. We love to do that. Unfortunately, as has been noted in previous talks, we're having problems with that, specifically bots. Lots and lots of bots come by. And it's been causing a lot of access problems for us. So we started off with our site's slow. Well, all right, easy enough. We can throw more resources at it. That will solve the problem. There are more bots. Well, we'll throw a few more resources at it. There are more bots than we have resources at a cost-effective level for a small nonprofit that works with the state. This is not shocking. So we said, well, what else can we do? So we started going, well, we'll try to limit some of the access to certain parts of our site that do not need to be publicly accessible, but were just because it was easy. And all right, well, we're basically doing okay. We're trying to rate limit some stuff. We think we're doing pretty well. And then we started to run into a problem. And we ran and still do run Islandora 7. So, by the way, I don't have any slides. It's because I came up with this talk a couple minutes ago. So, one of the things we started realizing was no one could see images. The site would load. They could browse around. They could search, but no images would load. Like, well, this is a bit of a weird problem. What's going on? So we started digging into our logs, and we go, all right, something's wrong with our image server. Keep digging around. Oh, the authorization token the browser gets is not correct. Ah, I know what's happened here. The table gets too full of data when bots get on there, and it gets locked up because it's trying to clean it out, and it locks the whole table. That's not great. Go and look in, I go, no, it only has one authorization token sitting around right now. That's not a problem. What's going on? We keep messing with it, and I've been asked to use the Blackboard by Slack, so I am actually going to do this. We started looking at the authorization tokens. I'm going to just write down the token we saw. I'm going to stop there. I think that's far enough. Some of you are already knowing what this looks like. Some of you might not. So we looked at this token for a couple minutes, and we're staring there. We're working like, this number looks really familiar for some reason. Why is this bugging me? I go, wait a second. What's the max value in a 32-bit field? Oh, oh, we have literally run out of tokens to authorize new image views. So it just kept reauthorizing the last token that it could fit on the field. And it just broke for everyone. So yeah, it turns out bots actually just exhausted our resource token allocation entirely because they went through it so quickly. We hadn't done any cleanup or work. It just cleaned it completely out. So the end result of this was that we had to restart that token count and then give it a larger amount of data to work with. But yeah, it wasn't even when we got crashed. They ran out of what we thought was a basically limitless resources. If we got millions of tokens and we're a small set of nonprofit viewing of old historical records, we're fine for a couple years. You know, it resets every time we upgrade the database. We're okay. But it turns out no. So that's my little lightning talk. Just keep an eye on your authorization token count or your integers.
Thank you. Thank you so much. If you're feeling inspired, if you're thinking, I have a sudden lightning talk that has come to my mind, if you're thinking, I want to use the Blackboard, I've been so inspired by Daniel, we do still have a slot left. So I just want to throw that out there now. All right, next up, we've got Matt Sherman with 90s Mac diskettes.
Hi all. I also do not have slides because I just thought this would be an interesting thing to riff on. So last year, so I work in Drexel University Archives, helping support a lot of the digital preservation stuff. So last year we were going through some of our old physical digital media and came across a set about 80 of the 3-something inch discs. We got our nice USB floppy drive, popped them in. It's like, all right, this isn't reading. Taking a look. And we could tell physically, oh, wait, this is a Mac disk because it has the requisite number of boxed out punch holes. So trying to figure out what to do with that because I'm running a Windows machine. But before I had thought to even grab a Mac, I was chatting with a friend who's into old computing, and he's like, yeah, modern Mac's not going to be able to read that, because it turns out Mac diskettes of that era were variable speed. So without a disk drive that could actually read variable speed, can't really do much with it. So I reached out to some of you guys who may or may not remember this on the chat, but it seemed like buying a CryoFlux was probably the only thing we were going to be able to do. But thankfully, it turns out that Drexel's computer science department has a little display of old tech. And conveniently enough, Drexel had a whole thing in the 80s where they had a deal with Apple to be sort of the first school to like require all their students to buy Macs. So we have a bunch of old Macs and a sysadmin who knows how to use Macs. So conveniently, we were able to work with him and disk image 80-some Macs, which was really helpful because when I looked at the A-Space record for these, there was a note on there. They had gotten this in 2005, and even at that point, they wrote them off as unreadable because a Mac just 10 to 15 years after these disks were written totally could not read them. So we needed something right of that era, and conveniently we had a tech professional that could disk image those and give us a little mini VIAC Mac ROM to actually run them on. We still have to find the software for them, and if anybody knows how to export data off of mini VMac, let me know, because it would be great to get all these like presidential records into a readable current format. But I just thought it would be an interesting little bit of sort of digital preservation to share, that old formats have more than just potentially irreadability due to OS systems. So if you're thinking about preservation long term, start thinking about moving things to more stable common formats sooner. And if you're dealing with old stuff, start looking for old tech, because that seems to be the best way to deal with them. So thank you.
Great, thanks, Matt. All right, next up, Eric Morgan, How to Make a Book.
Oh, hi, my name is Eric, and this is completely something different. Computers are really cool. I've been writing software since I was like 16, but you know, books have been around for a very long time. And it's really easy to make a book with just sort of the paper that you got lying around. And so that's what I'm doing now. All you got to do is you find yourself a bunch of computer paper, and then you have another, and then you can weave it all together. It's a whole lot of fun. So I'm going really fast. I don't have any sort of sense of what time is going on. And basically what I'm doing is I'm making slots and tabs. Tabs. Go, 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 go. I'm not sure how many pages this thing will have. I think it'll have about 64. I teach these workshops at school. I work at the University of Notre Dame. They're very popular. Making lots of little, what do you call these? Slots. Okay. And I tab some more. And if I do this, tear, 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 then I end up with these tabs, okay? So I can take a tab, and I can take a slot, and I can weave it in there like this, and it all sort of pops out. And in bookland, what do we call this? What? No, I'm not hearing it. It starts with an S. A signature. This is a signature. So I'm going to take another, make another tab, and I'm going to find another slot. Here's one. And I'm going to weave it in there. And now I've got two. Yay! And I've got another slot here. And I got another tab. I can put that in here. I think I'm up to 3. And I can afford to make one more. So I'm going to make another tab. I cheated ahead of time, and I folded my paper in half so I knew what the middle was. And here's my another slot, tab, weave in. Now I have 4. And then what you do is when you have your signature, you can fold it in half and you can make another tab. Yay! And then I can take this and I can fold it, take this in half, and I've got another slot. And so then I can stick the tab into the slot. This is a very mechanical process. It's not intended to be done in 5 minutes, but it will be very, very functional. So now I've got one going on here, and now I'm going to make another tab. You know, this is technology. No, it seriously is. This is technology. We talk about technology, and just think about when we had scrolls and wax tablets. That was a particular technology. And then this thing, this book thing, that was a different technology. And it had a number of advantages and disadvantages compared to the scroll. Like with the scroll, you kind of sort of had to start at the beginning and go to the end. You couldn't like go to the middle. But they get longer. Scrolls can get longer. Books are kind of stuck in their size. But they had a lot of advantages. Books have a whole lot of advantages. And I started libraries, not because I was into computers, although I was. I started libraries because I was interested in what's in the book. And in the book is knowledge and information. And the computers can help me do knowledge and information. But I can make knowledge and information technology like this that will last a very, very long time. And I think it's really kind of cool, kind of being balanced. So I got a very large book. That's all. Thank you very much.
you, Eric. So we have had a wide variety of different types of lightning talks, and we do still have time. So if anybody feels like spontaneously coming up, we'll give you a minute to sort of make your way down here. If you'd like to give a lightning talk tomorrow, the sign-up sheet is on a piece of paper near the desk, the registration desk. And, right, yay, we get a volunteer.
Yeah, so a few people. It's Kate Dybel again. Those who were not there in the morning, I gave the talk about making dev teams more inclusive. And I got some, thank you all for the great comments I've received. I love that. But a few people asked if I could maybe talk more about what I kind of sped through at the end, which was about on how I actually model my my various disabilities to my bosses. This is something I've developed after running into trouble at work at times where things just get too frustrating and unfortunately emotions flare. So this kind of, being autistic, I'm very much about trying to figure out procedures. I describe my entire interaction with people as massive chained if-then statements that I've actually had to learn that most of them were innocuous. Most of you people do weird things with your hands that are totally have no meaning apparently, but tell that to 8-year-old me and it would make life a lot easier in elementary school, middle school, high school, college, grad school. Took me, I can say I'm starting to figure it all out. But so I kind of came up with these. And my first rule is, and this is the one I say is the combination of that I have insomnia, depression, and I think all the time, my brain doesn't shut down. I tend to think really big picture. I say it's a lot of people do say, and this is on how I approach it. It's I'll just start over a little bit more because I'm improving this. I start off this when I started at PCOM, my first day, I told my bosses, I'm going to give you some advice on working with me. This is sort of like the little tricks of the trade I've learned about working with, I call working with Kate. One, I do tend to picture these big things and I connect with them. It's I will see chains of, impact. And so I will literally be at the point of thinking about A implies Q, but then realize nobody's even considered how H through M applies in there. So it could be platypuses on Jupiter. There's some connection in there. And this is why I'm good at really bigger problems or seeing a full process. Why I actually love my system job in a small library where I have to be involved in the whole library. The other thing is though, it's so please, if I'm talking about something that seems irrelevant, ask me why I'm concerned about it. That's the big thing there. It's just giving them that little permission. I usually have a reason. Just tell me if I'm forgotten to not assume everyone's in my mind and has been thinking about things like this at 3 a.m. for years. Any reason? Are you surprised that my dissertation had 3 separate reference chapters? The other one I talk about is, as I said briefly, is that my ability to communicate begins to break down if I think something's really important, but I'm not finding the right way to articulate it. And the more I get shut down on that, the more just gets frustration. And so what I share is if you see me really starting to shut down like that, I work hard on not letting myself get to that point or trying to accuse myself, but it helps a lot. If you recognize Kate's trying to come up with how to phrase something really important in here, Kate, take a moment. We can all use a quick break. That helps a lot there. And I've actually been toying with a third one, which is this thing about a lot of times when I ask a question, I'm literally asking just that question. I'm wanting to avoid the snowball effect. I'm going to say this, as tech people, we want to solve all the problems. And that can be a really big deal for me. So I'm still working on how I will share this with people. And it's something I recognize I need to work on because I've been coming off. I apologize to any of you who've faced this, where I've said, hey, can you just please stop? I have the solution I need. Do not keep telling me about this. Or it's like, I asked about power strips. I don't need to know about an APS power supply or anything like that. And it's just a matter of saying, there are times where the more information you give to a neurodivergent brain like me, the more you are overwhelming me with knowledge and facts and things to consider. And I'm going to just kind of end this with just going if you're a person you're considering doing this, one, practice it. You have to come up with how to naturally do it. And the big thing I found that makes it work is that I'm approaching it by saying, this is why it's difficult for me. I'm aware of this. And as part of this process of avoiding getting into bad situations is not to completely avoid it, but be able to work on it. And it's one of those where if you can help me along with that, we will work better with that. But the goal here is not for you to just accept it. No, we're supposed to work together. I'm supposed to be as kind to you as you are kind to me. Your being kind to me will be listening to this advice. Now, I will tell you, the one boss that totally failed to do this for me was the one that the moment I mentioned, on how I think broadly, it goes, oh yeah, we're all big thinkers here. And I'm like, wow, we're all the same in that we're all different. That's, we all have melanin in our skin in different ways. We all have sex hormones. Talk about just being completely dismissive to a person who just opened up to you. That's not how you do it. As a manager, you should go, actually, the best ones have been I like my employees telling me on how they work better. I don't have to figure it out. So that's just kind of it there. I've been slowly figuring this out over the years. The nice thing is about my flavor of autism is that I'm overly blunt and honest, often to my detriment, but I'm willing to share it like this. So thank you.
Thank you so much, Kate. Let's give a big round of applause for all of our lightning talk presenters. All right, now we're going to move into our first afternoon block of presentations. We're going to have 4 presentations, and then we're going to have our break. All right, okay, great. Our first presenters are Lauren Galina and John Dewey's. They're going to have a 15-minute presentation.
Hi, everybody. I'm John Deweese. This is Lauren Galina. We're from the University of Rochester, and we're here to talk today about digital projects governance, getting everybody on the same page, because who can't resist a library pun? So the point of the Digital Collaborative Governance Team, which is what we're here to talk about today, or DCGT, is to figure out how to get a bunch of different departments and stakeholders such that they can work on projects successfully. When we created the DCGT, we had come out of a period of time where those relationships between departments had really broken down, and we were finding it difficult to progress our work at all. The primary 3 words in the document outlining our charge and scope are collaboration, communication, and coordination. Creating an environment where these departments could successfully work together and collaborate at all was a necessary foundation, as some of the departments involved had essentially stopped working together in any fashion whatsoever. A breakdown in communication was one symptom of this, so one aspect of this governance group is simply to have an official and regular arena for communication through our all favorite thing, which is meetings. We also ensure that we communicate with the rest of the organization by making heavy use of our intranet. We publish all of our meeting notes as news posts and have a landing page where we can share all of our artifacts and project roadmaps. I've often heard some version of, what does that department even do all day at various workplaces? And one thing that this communication strategy tries to address is answering that perhaps sarcastic question seriously to make available information on our work for anyone that wants it and to build up a knowledge base over time that will hopefully help future versions of us or later folks that step into our positions. Finally, having insights into each other's work and involvement on projects lets us coordinate more effectively by understanding capacity issues in other departments. This way we can try and sequence our work intelligently to be more efficient and to help us hack away at our backlog of projects. We don't cover every single project that involves a digital within the library, but we specifically tackle projects that involve digital collections, from special collections and also including web archiving, digital exhibits, and some sundry other projects that don't fit into a neat category, but are essentially legacy digital humanities projects that we are continuing to maintain for now. This group brings together a fair number of people, including the relevant administrator that oversees most of our departments involved with this work, some of the heads of those departments, and the actual practitioners doing the work. These last folks are oftentimes let out of the loop when it comes to making decisions, so we were quite adamant about their inclusion. From a service point perspective, this involves digitization, metadata, and digital asset management, along with our special collections departments holding all of our coolest collections. We're also lucky to have a dedicated project manager to help us stay organized. Okay, so I think a lot of library IT departments have gone through a process where for a lot of years they had to support bespoke digital projects with no real path to sustainability that eventually become so sclerotic as to either necessitate being shut down or require a huge investment to keep them running. That was certainly the case with us, and our technical debt kept building and building, which required a fundamental rethinking of how we operate. Because we had so many seemingly insurmountable issues, a lot of work related to the new projects was essentially frozen. No major collection digitization and description efforts have been undertaken in the past several years, and we had no clear means of digitally preserving any of the things that we were stewarding at all. This led everyone to feel even more siloed away from one another, and there was generally a sort of widespread feeling of acrimony from all involved. We had multiple Island Door instances that were based on Drupal 7, which just hit its official end of life at the start of this year, which lit a bit of a fire under us. To be perfectly honest, the fact that the Drupal 7 end of life kept getting pushed back was an absolute godsend for us, and we weren't at all ready for the necessary migration work to different systems to happen, and we did not have the capacity in-house in order to make the Drupal 7 to Drupal 10 jump that would have been necessary at the time. We sort of lived that old saying of if all you have is a hammer, then everything in the world is a nail. But for us, that was Drupal pages. We had Island Door instances that needed to be handled, but also had hundreds of static Drupal 7 pages that contained a huge variety of content that needed to be migrated to all sorts of different systems. It might be archival collection descriptions, indexes, small digital collections, transcriptions, all sorts of content that curators had created because they helped the research process, but didn't really have a good home after that. We also have a homegrown DSpace fork for our institutional repository that was developed well over a decade ago and haven't had anyone on staff that knew the code base for years. The fact that some of these systems were able to continue functioning at all is honestly something of a miracle. Being able to sustainably address challenges such as these and then make better decisions going forward is key to our work. Employee churn was also a major issue, as someone might develop a solution that was really oriented around their own knowledge or skill set, but without anyone else that could step in once that they left. That DSpace fork is all built in Java, and we don't have anybody on staff that knows Java. This was a major reason for trying to move to an enterprise systems model. Many of the systems are cloud-hosted SaaS platforms that are well documented and understood, where there is a good expectation that others in the field would have competencies already should we need to hire them from into the organization. We now have designated platforms for various functions, such as Omeka S for digital exhibits, Preservica for digital collections access and digital preservation, Archive Space for finding aid creation and publishing, ArchiveIt for web archiving, Asana for project management, as well as structures around how service points like digitization and metadata creation should function. We've mostly managed to get beyond the Drupal 7 migration hump, which took us about 18 months of work to complete. However, we still have a lot of work to do when it comes to migrating exhibits from Omeka Classic to Omeka S, getting assets off of external hard drives and file shares and all of that into Preservica, and other crucial, but fortunately not software end-of-life driven objectives. The DCGT itself is all project-based. These might be discrete projects, such as a platform migration, or even a project to stand up a new service point that is then run by a department. This requires a lot of communication and coordination to ensure that everyone understands what is on each other's plates, and how we finagle our capacity together so that the work can progress. We've been developing policies, workflows, guidelines, seemingly never-ending numbers of documents to codify all this work, which Lauren will now talk about.
As John mentioned, a lot of the work our team has done has been around creating documentation to define the work that DCGT does and can do for other staff who are interested in working with us. All of our documentation is organized and made available to staff through our intranet site. A good chunk of our documentation outlines the services that we provide and alternatively what is out of scope. This can be found in our service level agreements and service models. Service level agreements were written specifically for our enterprise systems, while the service models are for services that are not tied to a specific system, like metadata and digitization. These documents were written by the practitioners who work in these respective domains. Additional policy documents were created for anything related to a service that did not fit within those document definitions. For example, as the metadata projects librarian, I worked on the service model for the descriptive metadata service that I offer as part of DCGT, and I created metadata application profiles for the 3 digital collection platforms that we use. Our team also created workflows specifically around managing projects and slating them onto our quarterly roadmap. In addition, we allow any library staff member to submit projects to DCGT each quarter, and as a group, we have collaborated on the documentation that provides instructions for what staff need to submit to us for their project to be slated on the roadmap. We also have a slew of governance documentation, including charge and scope, working norms, and an outline of tasks for facilitators, which includes things like onboarding and offboarding members and scheduling meetings. So you may be wondering, how do we manage all this documentation and make sure it's up to date? Well, there's a document for that. Our DCGT document review calendar, which provides a timeline for when groups of documentation should be reviewed and who is in charge of doing that review. And the screenshot that's up on the slide here, it's just a snippet of our service catalog, and it shows the descriptive metadata service and all the documentation that I've written for that. Overall, our shared governance team, DCGT, has been beneficial to the way our organization handles digital projects. Though the amount of documentation we have can be overwhelming even to us, it is something that our team has all contributed to and clearly defines the work that we do. Everyone in the group has signed off on the documentation and always has a chance to make any updates through our document review cycle. This collaboration allows team members to buy-in and feel like their voices are heard. We all participate in the creation of our shared roadmap using a rubric we developed, and our work for that quarter is outlined on that roadmap. As mentioned in my previous slide, we have documentation in place which supports stakeholders who submit projects to the group. Our roadmap additionally allows us to keep projects moving forward as we have a space blocked off each quarter for backlogged work. Perhaps most importantly for goal setting, our work through DCGT, and especially with our roadmap, allows for projects to be visible to library leadership and others within our organization, allowing everyone to truly be on the same page. So one of the reasons we wanted to do this talk was to share the work we've completed. So maybe you're in a group like this at your own institution but haven't codified it yet, or maybe you're looking to start something similar at your institution. We've uploaded our documentation to our institutional repository for anyone to view and download, and it's available through the URL or QR code that you see on the screen. So that links to this presentation, and then there's a link out to the documentation that I mentioned. And that's our presentation. Thank you.
Awesome. All right, we have time for questions. Do we have a microphone? Reiner? Yeah, there we go. Oh, got one up here. Oh, up in the, if you could raise your hand again, thank you.
Hi, I'm Kim from Princeton, and I sat next to you at lunch. Nice to see you again. I had a question. You mentioned a rubric, and I wasn't sure if the rubric was also available, just to get an idea of some of the things you were thinking about with prioritizing your projects.
That's a very good question. I actually don't remember. I don't think we have, but that's a really good suggestion. We'll add it. Yeah, absolutely.
Oh, thank you so much. I'd really love to see it.
Hi, thanks so much. I'm Kelly from Clemson Libraries. Can you give me a count of the number of people who are in the group?
Yeah, it just changed. We're at 8 people currently.
Did you mention what platform you guys are going into? I'm sorry, I missed that while I was typing.
Oh, from Islandora?
Yeah.
To a bunch of different places is the answer. For digital collections, we're hosting it through Preservica, but a lot of that stuff, it was more a digital exhibit in nature, just happened to be in Islandora or a Drupal page, and is going to OMECS instead.
Okay.
There, Emily Ann from the University of Buffalo, so we're kind of neighbors. I had a question about the membership of your group. How much technical membership and involvement would you say? Do you have maybe like systems librarians, systems admins involved as well?
I'm trying to think. Our system librarian mostly works with Alma, so he's not really involved. John has a lot of technical background since he's our DAM librarian.
Best title I've ever had.
Not
Just
really.
curious,
It's
yeah.
mostly like the people that work with the digital collections.
Because I know so often you are fighting with the underlying Islandora, Drupal, et cetera. So just curious.
Yeah, I've done a lot of technical work in Preservica myself, or trying to figure out XSLT and the facets and everything with that. So I think it's just mostly within our group, the technical knowledge, just working with everyone within the group already. Yeah.
Cool, thank you.
If no more questions, give them another round of applause.
Thank you.
Thanks. All right, our next 3 presentations before the break are each 10-minute presentations. And first we have Sarah Hensler.
Oh my goodness, thank you. Woo. There we go. Now we're cooking. Okay. Hi, my name is Sarah Hensler. I'm a grad student at Indiana University, and this is, if you give a girl a website, she'll ask for metadata searching. My website is called Windows to the World. It is a K-12 curriculum platform that is designed to take a bunch of already digitized items from a bunch of different museums, archives, and other repositories on Indiana University's campus and make them accessible to K-12 teachers by combining them with metadata contextualization and additional resources, and a few drag and drop lesson plans that other teachers from the community have made and given to us. In other words, the goal of this site is to take teachers who can't engage with archival materials on their own and allow them to integrate global content into their classrooms. The website itself, my apologies, the link is the one accessibility fail on this. The website itself was built in 2021 by university WCMS designers, which is the best thing that our international studies department could afford at the time. And that works about as well as a archival database as you would imagine. The site is also maintained by a crew of fellow grad students who are working part-time and haphazardly. And the simple answer is that this website doesn't do anything we need it to. It's not a database, it doesn't have metadata searching, it doesn't have a citation or captioning system really built in, so we have to kind of manually do it within each item page, and there's no linking between items. So it's basically unusable. And when we first started talking to our museum collaborators who give us these items and expect to see them represented on the site, they asked that we just give it metadata searching. Because if you can search by the metadata, that means that the metadata is there and properly formatted. In other words, we would just restructure the WCMS to have some kind of central, like CSV-based graph or chart where we could put it all in. And unfortunately, the second we tried to do that, we realized that that doesn't fix it at all. And the reason is as follows. For the museum educators, metadata searching does fix it because these are people that work with these items day in and day out. They understand the metadata they work with and they know what these terms mean. What they want is to be able to find it quickly and accurately and respectfully with a lot of room for nuance built into the controlled vocabularies that they provide us. In other words, they want our system to look as much like their system as possible. However, we're aiming to present this to a team of K-12 teachers who have never heard of any of these items before. Sometimes even the basic name of the nation is unfamiliar to them. And so giving them metadata searching doesn't actually increase their ability to engage with the items or allow them to successfully link disparate items together in a way that supports more complex and thoughtful global content. So this ended up leading us, much like in the if you give a mouse a cookie story, it led us from just doing metadata searching to asking a deeper question about how can our metadata and the way we present contextualizations of it drive educational engagement, especially when you're working with children between the ages of 5 and 18. The way we decided to examine this and give ourselves the best shot of creating something useful was to look at the 51 teacher lesson plans already given to us on the site. So we took each of these lesson plans, which covered all grades and all subject areas, K through 12, and we evaluated every single one of them for the metadata fields that the institutions provide us. So we looked at the title, the maker, the date, the material of the item, the size of the item, the country and culture of origin, the credit line from the museum. And we decided to evaluate the extent to which any teacher was able to integrate those metadata fields into their lesson plan. What we found was that the most popular fields were the function of the item, its country and culture of origin, and the material. And this makes sense because if you've ever shown a new item to a kid before, the first few questions you're gonna get are, what is it? What's it do? Where's it from? What's it made of? Can I touch it? No. But by contrast, we were surprised to find that the unpopular items were things that in a physical archival setting were pretty obvious. The maker, the date, and the physical dimensions. Now, the maker and the date are typically obvious in a physical museum setting because of the way tombstone information is presented to the viewer. You have the item on the wall or in the display case, and then next to it you have the tombstone information, which typically says, in order, the title, the maker, the date, and maybe the country. But the physical dimensions was one that we were really stuck on because it is so obvious when you look at an item in person how big it is. You might not know my size in feet and inches, but you can guess how big I am. And if I hold up my phone, you can probably guess how big that is too. But if you've never seen a phone and I give you an isolated 3D rendering of it, you probably don't have a lot to go on. And even if you understand in theory how I use it, you might have a really distorted view of how I use it or what that says about me as a person. So in order to better understand why the physical dimensions, the maker of the item, and the date behind it were so difficult for teachers to work with, and understand how maybe we could better integrate it, we then decided to look at the lesson plans by their subject area. To no one's surprise, social studies was the most popular. This is a digital humanities site with an emphasis on geography and history. But more surprisingly, English was far and away the second most popular, and particularly English lesson plans that covered grades like K through 4, and then grades 10 through 12. And we decided to go into the Indiana State Standards for more context on that. And we found that those are the grades where the state standards for what you teach children in those years are the least forgiving for international social studies content. So starting in 4th grade, you have your state history year, then there's your national history year, then there's your mandatory ancient Greek and Roman year. You maybe get like 1 year in there for like China and the Silk Road. But there's a very specific period of time when teachers are constrained in what global content they bring to their students. And because English, especially in its very early years and in its much later years, is about making comparisons and contrasts between disparate cultures, it's a really easy way to shoehorn in global curriculum where your pre-existing standards might not allow it. And that helps it articulate why the dates and the sizes of items aren't getting used as much, because it's harder to bring up a date in an English classroom compared to in a history classroom where you're already asking students to consider things on a timeline or on a map. So how do we actually condense all these things into something functional for teachers? Firstly, we decided to start pairing our numerical metadata, so timelines and temporal data for items, and then scalable size comparisons for items to the social metadata attached to it. So if we have an idea that the date an item was made matters to the item, it matters as a metadata field and we should include it, then we have to have a warrant for it in the social metadata. We have to find a way to contextualize it within what we want teachers to take away about this culture, bearing in mind that your average elementary school teacher has maybe an hour to prep any given lesson plan for any given subject. For an example to show like how this might actually play out, I included this image of a prestige hat from the Bamileke culture, courtesy of our Eskenazi Museum of Art on campus. It's really hard from looking at this hat to judge how big it is. I worked with this item digitally for over a year, and I kind of went back and forth mentally and imagining it as like a gigantic ceremonial headdress or like a little bun cover. Turns out this item is about like 24 inches by 24 inches by 18 inches, which is almost impossible to visualize if you don't have it on a person's head. And that led us to some of these ideas. First of all, we are still going to showcase the standard metadata. Having a website where you can't search by all the relevant metadata fields is ridiculous. And for our museum educators who need to be able to find their own items within this site, it's important that we give each item the proper credit it's due. Some of our basic fixes for that include just reformatting the image so that it actually shows the whole item. It also includes, like any normal database, transferring all of the search filters to the left side of the screen so that you can continue to adjust the filters after you search, and providing a wider variety of those search filters. Secondly, we're now focusing on this idea of scaling items, which is the part where I thought I was going to be doing a lot of hard coding, and instead means sitting in a lot of really interesting conceptual meetings with museum educators and international studies specialists about how do we place items on a timeline, or how do we place items next to each other in a way that's still respectful. For a lot of our context for this, we've been using the National Archives as a good pull for historical timelines, because they have this capacity to do time like regions instead of just singular dates. When you work with especially anthropological items, you have a lot of uncertainty in dates, so being able to stretch those dates matters a lot. NASA has been our primary source as we started making wireframes for comparative item size scaling, because NASA is so great at taking items that are never physically in the same space as each other, can never be photographed together, and being able to draw them into a good conversation with each other, like the Milky Way galaxy and the sample of an ultra-compact galaxy, which I can promise you are not that close together in real life. And lastly, we started to reimagine the way our thematic and subject hubs within the items work. These are all wireframes that just use the same item and over and over again, but imagine that instead of just seeing the same teacher-made activity 3 times over, you're instead looking at a collection of 3 different lesson plans, all designed to bring you to the same thematic topic, like clothing, or maybe the way we honor our dead. If you have any more questions about any of the things I showed, any links, etc., they're all here, and many thanks to the rest of my grad student WTW staff team.
Yeah, you do. All right, we have time for questions.
In terms of the scaling methods you were talking about using, what tools are you using to kind of keep them up on the site and present them along with the actual content?
So that depends a great deal on what our museums provide us. We kind of operate at the leisure of our different institutions, and our institutions are also providing items to us depending on what they've already had the budget to digitize. So one of our partner museums, the IU Museum of Archaeology and Anthropology, has a few excellent 3D renderings that are on Sketchfab, and so we're currently working on essentially merging those Sketchfab 3D visualizations so that you can look at them together and manipulate them in tandem. But for our two-dimensional items, which is the vast majority of our collection, we are essentially looking at creating a separate page, massive pop back here, a separate page on the website that presents a static version of that scaling chart with possibly all of the items or a key sampling of them. And a lot of our conversation right now is beginning to revolve around what items do we use as our scale source to engage with kids, because it's easy to say like, okay, you know, an adult man is like a good comparison for scaling clothing. But, you know, if you're working with a third grader, does a third grader care how big a grown-up is? Does a third grader want a third grader as the scale comparison? Or a school bus? Or we talked for a while about using a pencil for some of our smaller items, and then we were like, wait a minute, how many third graders even use regular pencils? Like, do we have mechanical pencils? Like, I don't know, like iPad covers, the little gummy ones? Like, what do people actually use as systems of scaling? But it will likely be a static chart that you can scroll along on a page. Yeah, the banana is also high on our list, because I think children still eat those. I'd like to hope.
Hi, awesome talk. I really enjoyed hearing about how you went back to the users and gained a lot of insights with some of the research, and it sounds like you were afforded, I guess, or provided with a lot of ability to go back to them, learn from them, learn about their needs, and ask like those 5 whys and learn about them. I was wondering if you got to take some of your solutions back to them and test them out iteratively through the process. And so I'd love to hear a little bit more about that, and also if there's anything that really surprised you. And you've already kind of mentioned like, oh yeah, do they use pencils anymore? Yeah. I don't know, like that's.
Well, so the reason I can't answer it fully is because it's happening tomorrow while I am not there. So we every year do an annual cycle of teacher workshops where we invite a cohort of like 20 to 25 teachers from various disciplines to come in and work with our items and learn the site and create. That's where our pre-made lesson plans come from. And yeah, our focus groups start tomorrow. Well, I'm not there, so I'm very anxiously awaiting news from my coworkers and my big supervisor who will tell me how it goes. So far, what I'm anticipating hearing from teachers is a desire for a broader spread of cultures. I think every time we talk with them, they want to see greater variety in the content. What I would love to do more testing on, if that's what they continue to ask for, would be to see the extent to which they actually make use of a high variety of items, because I do think, despite them saying, no, we know how to use it, we just want more, I think they still tend to fall into the same ruts of preferring the same semi-familiar items. Like if you give them African items, they're going to prefer Kenya. And if you give them European items, they're going to prefer ancient Rome or France. And so I do think that there is still a need to dig past their impression of, oh, if we give them a high variety of items, then we'll take advantage of it, because I think they do still have an instinct to revert back to things that feel comparatively familiar. But that's just speculation. I will know more come Tuesday.
I have a question. Yeah. I'm Richard Higgins. I'm also at Indiana University, and I have a particular loathing for WCMS, otherwise known as Cascade Server, which is, we don't use it at the libraries, but it's kind of forced on most of the campus. Is this a different platform? Is it a specific platform that it's on now? That's my question.
So it's still housed through the general university WCMS. It's basically like an adjacent, I think what they did, and this is my best guess based on how it was explained to me when I came on the project, because it predates me by a few months, is that they basically took the Hamilton Luger School's different International Studies Center pages, and then they like direct copy and pasted that. So it's, the web page is just www.indiana.edu, and it is almost page for page a direct recreation of any HLS page you find on there, with the exception of this one like jerry-rigged search page that they've got pulled up. I think it will likely stay that way moving forward because of the way budgeting goes for the site, which is, you can imagine, our museums, that some of which use a university-wide collections online, and some of which use A-Space, and some of which use secret third things that I can't even access. You can imagine how thrilled they are by that.
Thanks.
Sarah, another round of applause. Thank you, Sarah. And next up is Emily Lynham.
Is this okay? Seems a little low. I'm actually setting a timer because, I only have 10 minutes. I don't know why I keep proposing 10-minute talks. My name is Emily Lynham. I'm the head of digital media software development at Indiana University Libraries. I'm going to talk a little bit about Whisper today. First talk about Whisper, but there'll be more. I really don't have time for this slide. Just suffice to say that we've digitized in our mass digitization project over 350,000 audiovisual media items over the course of the last 10 years, and we continue to digitize. So we have so much historical stuff to make accessible, and so we wanted to ask, could we use Whisper to create good enough captions without human review? And one, because we don't have the humans to review, and one aspect of this is some of this is older materials, so we didn't know if that would matter. So our goal is to test Whisper against a variety of content genres and physical media formats. We just chose English language on purpose because it is our primary language, and spoken word, we have tons of music, but we know that music is harder to do. And we wanted to ask, will Whisper be good enough for accessibility and discoverability? So our content genres, lots of educational recordings and broadcast TV. We did find a few field recordings to include. We have lots of field recordings, but we were aiming for materials that were public and also not music, so a lot of them have music. And physical formats, we tried to get a broad representation of the major formats that we digitized. So you can see here we have a number: motion picture, film, and audio cassette are the most, but we did find 2 wax cylinders we got to try, so that was fun. So we sent these materials to 3Play Media for human transcription, and then we ran several different Whisper models on the HPC cluster at IU, where we have access to GPU nodes, which we do not have otherwise. And we did try a couple of FFmpeg filters. We normalized the output from 3Play and Whisper because there are things like punctuation, capitalization, okay versus okay. Those things are not important errors. And we calculated word error rate and word info preserved. So my boss made these cool scatter plots, so I have to give him props. But so this is content genre, word error rate by content genre across the runs for large V2 and large V3 models. And you can see what's interesting here is we see some really obvious clustering happening. So the green cluster at the top circle, these are field recordings. So field recordings are averaging between 20 and 40% word error rate on the sample of 3 that we had. So that's pretty not good. But if you look at the bottom in the red maroon cluster, these are educational recordings. Oh, I'm too close. These are educational recordings. And these are averaging between like 1 and 8% word error rate. So again, this seems like a very obvious cluster of content genre that could be useful for us to target. We also looked at it by format because we cared about format. And you can see here the clustering is not as obvious. So for almost every single color here, we see a stack ranging between like 2% all the way up to 25, or those VHS is where the field recordings are over there, the blue ones that are way up at the top. The purple and the green are the two that sort of have the lowest concentration. Those are LPs and motion picture films. When I looked at the content genre of those materials, it was all educational recordings or broadcast TV. So again, stuff that is of a genre that is more welcoming to a tool like Whisper. So just to mention, the FFmpeg filters we tried, it was very variable. Whether or not it improved things, we looked at volume increase, noise reduction. We looked at the condition on previous text whisper parameter. Again, no obvious clear improvement. Not surprisingly, large V2 and large V3 were the best, but Turbo Model was recently released when we were doing this, and it is promising because it's so fast. It's faster than medium model. So again, back to this question. And the answer is like, of course, yes, sometimes it depends. You can't guess that from the word error rates I already showed. But I mentioned educational recordings. Yes, these could be used. So they average 3% word error rate with these models. I looked at a small sample size of just 2. There were 5 to 10 meaningful errors in 15 minutes of content. Of those 5 to 10, maybe 4 actually would have been confusing to a user. The transcripts look good, they're readable, and again, this is because we often have a single narrator. They're speaking slowly and clearly in English. There's not a lot of music or other background noise, and there's fewer like proper nouns or localized vocabulary being used. Other content is more it depends. So I have a couple of examples from broadcast TV. This first one is series of TV ads that does include jingles, which could be hard because they're musical, from 1960s. The word error rate is 6.14%, which sounds low, but not that low. And the word info preserved is 91.26. That's how much of what was really there did Whisper get. And so how many of these errors were meaningful? This is just me. I looked at it and I made little scratch marks. I counted what I thought were 15 meaningful errors, but fewer than 15 actually would have been confusing. The first example you see here, where Whisper substituted around for year-round, could be a little confusing to the user about what it's trying to say. But we have 63 of the errors were not meaningful, representing differences in writing style, transcription style. The second example on the bottom over there is just a different way to write a stammer. Someone stammering with the word cooperative in an ad, a kid. So totally valid, it would be understandable. Is it readable? So that's the other component, like if I showed it to a human. So yes, this transcript, I've highlighted here in bold the one like capitalization punctuation error that I found in this transcript in the 15 minutes, so definitely. So looking at the errors for this broadcast TV, this is something that was like produced and aired, totally valid for humans to use for accessibility and for searchability. This example is a little tougher. This is unedited news footage, so not as well produced. The word error rate's actually, the one thing I was gonna say, the 6.14% word error rate, that's kind of high, right? For something that looked so good. It's because Whisper inserted transcription of vocalizations that actually were usable. They just weren't included by the human transcriber. So human transcribers make choices. In this example, the word error rate is just a little higher. The word info preserved is a little lower. Meaningful errors, I looked at just the first 15 minutes of this. I found twice as many meaningful errors. This is where we start to see hallucinations here. I've got some YouTube hallucination. Apparently, what the hell is in the training vocabulary training corpus for Whisper? And 40 errors that were not meaningful. I did include in not meaningful things that were the local newscaster saying their name and place names. I wasn't sure whether a human transcriber would have actually known how to spell those things either, or whether they just made a guess. Is it actually readable? In this example, a lot of it is, but here's one snippet from the transcript that was all caps for some reason, and another snippet where they just didn't include any punctuation. I don't know why. But a lot of it looks like this, which is fairly reasonable. But based on seeing hallucinations, seeing more errors, looking at a transcript that's not as usable for the user, I would say, I don't know if I would want to present this to a user. I would want to consult with a collection owner. But for searching, it would be very useful, and especially useful if we could connect the transcript out with an authorized place names for Northwest Indiana, because that's a strong use case for this collection, is finding footage of localized to Northwest Indiana. I have 2 minutes. Okay. So I said I would talk about an example, and we didn't get done the thing we were going to do. But we did work a little bit with the WFIU Public Radio Project at IU. So this is a public radio station that's been around at IU since 1950. They have their materials have been digitized, but they have no metadata, really no metadata in their stuff, and they need to be able to find things. So they want transcripts that staff can search. So they're really concerned about staff. I don't have any ground truth. They didn't really have any interest in creating ground truth. So I just did some testing on a sample set with human review. I was the human, it was me. And the interesting part about this is that we chose to use Whisper Medium model, which in the other examples I showed was not usually the best performer. But this content is public radio content, which at least for Indiana University often includes extended musical segments split up by introductions or discussion. And hallucination increases for large or turbo models with music. So that's something we've seen in the past. Medium model handles music with less hallucination. Content influences model choice. So yes, we learned Whisper captions are likely good enough for some content genres. Regardless of physical media format, background hiss did not seem to be an issue. Word error rate doesn't tell the whole story. Human transcribers do make mistakes. And some areas we'd like to explore is finding things that are likely to work well beyond just this category of educational recordings, which usually we can tell by the collection. How to prevent hallucinations, how to improve the captions produced. And then I just relearned about this concept of semantic distance. Another way to determine in a programmatic way, is this error meaningful by measuring semantic distance between two sentences? And just a plug for the AI for LAM speech-to-text working group, which is co-led by Owen King, who's going to present later today, a monthly call on the 4th Tuesday where we talk about stuff related to automated speech recognition. I think that's it. I think I had any question time. Oh, she's giving me a little extra time.
Hi, have you looked at any of the Whisper variants that can be used to identify non-speech? So, our use case is very similar. We're interested in using Whisper to create captions. And given the context of my institution where we work, we're particularly concerned about the quality and sort of the extent of the captions that we can get in terms of doing things like speaker diarization and identifying non-speech. So I'm something I'm in general interested in, and curious if you all have been thinking about that.
Yeah, we haven't explored that. There may be some folks over on the speech-to-text working group who have experimented with that, because there's generally somebody who's tried out every sort of new variation, but we have just been using the base Whisper model.
You had mentioned hissing as one of the things that didn't really have, but did you guys do any pre-processing, remove dead air, volume normalization, bypass filtering, whatnot?
Yeah, we only stripped dead space at the end because we wanted to be able to use the outputs more easily without having to add the dead space back into the beginning of the transcript if we ever actually use the transcripts we were creating. So we stripped dead space at the end because we do have lots of that. We did some FFmpeg, we did noise reduction and volume increase. Those were the two things that we tried, and it helped sometimes. It made it worse in other times. So it wasn't clear for those. Those are the two things that we tried with FFmpeg.
Last question: did you try doing the channel isolation as well, or?
I don't believe we did that.
Oh.
Hi, Mike Andrew, Ukrainian History and Education Center. I've had this idea of, could you potentially do multiple runs on maybe with slightly different parameters, especially in cases where you don't have a ground truth, to maybe it'll behave differently or hallucinate differently, and then you can use that to spot where issues might be. I haven't tried it, but that's occurred to me.
Yeah, that's a really interesting idea. Why do I feel like somebody has talked about that recently somewhere, but I'm not remembering the details? We haven't tried that, but that's an interesting suggestion of like isolating hallucinations or areas that are problematic when you don't have a ground truth because you have no idea if you don't have a ground truth whether there's a problem, and comparing runs of Whisper and seeing where there are differences between two runs. We have not tried that, but that's a really interesting idea. Because you have that problem of you just don't know if you don't have ground truth, which you almost never have ground truth. I mean, that's why you're using Whisper.
All right, let's give Emily another round of applause.
All right, hello, my name is Harpo. I'm a senior developer at the GBH Archives. You might have know us by our other name, WGBH, or if you've seen any of these wonderful programs. Actually, if you haven't seen any of these programs, I would like to know how. But in addition to the GBH, all this wonderful GBH content, Nova, Frontline, Masterpiece Theater, Arthur, Antiques Roadshow, and all those, we also host the American Archive of Public Broadcasting, which is a collaboration between us and the Library of Congress, and it's an effort to preserve and make accessible content from public broadcasting stations, television, radio, all over the country, and internationally as well. We have stations in Puerto Rico, American Samoa, and Guam. If your station is not on this map, please let us know. We'd love to include you. We have over 2.5 million metadata records, of which we have digitized about 213,000-ish assets. And of those, we have 127,000 available online for free for everyone in what we call our online reading room, which we're very proud of. So I know I would like to spend a moment asking why transcribe and archive, which I know seems a little silly for an audience like this, but in brief, a lot of our records have very little or even no metadata sometimes. All these records here just say no description available. Sometimes it's just a title or whatever was written on the tape as it was digitized. Some of these stations have not the best record keeping practices, or maybe they did and they've lost the records over time. And sometimes something as simple as bad handwriting can cause issues that we'll see in a minute. So we have tens of thousands of these assets that are effectively undiscoverable. And if you want to find something that you're looking for, you would have to know exactly what it's called in advance, or just start watching everything and hope that you get lucky. But even that might not be enough, because we have some examples of some incorrect metadata. For example, this record that we found recently, a series called Roman Catholic Protest and Colloquium at Harvard University, which our head archivist thought that would be very fascinating for something in the 60s, and did some research, and turns out it was a Catholic Protestant colloquium at Harvard. A little bit different. So that record has been wrong for however many decades it's been in the records, but if you look at the transcript, the first sentence does correctly identify what the program actually is. So having a transcript in this case helps keep this record discoverable and searchable. We have a saying in our department, accessibility over accuracy, and thanks to Sarah for giving the previous presentation, covered a lot of this. 90% accurate is good enough. That's actually more than good enough for us. We would much rather have a bad transcript available than no transcript available, because it increases the discoverability in our in search index, and also we put this disclaimer up for uncorrected transcripts so that people know that this was made by a computer. So Whisper was not our first attempt at automated speech recognition. We had an earlier attempt with a model called Caldi, and it was all right in that it worked and it was automatic, but it was not effective. It was basically unusable with a 49% error rate. It required lots of manual corrections and was not fun to work with on any level. So imagine our surprise when one day Whisper shows up and cuts our error rates in half, and also our processing time as well. We were understandably very excited. Whisper was released in late 2022, and we quickly started working with it to integrate it into our systems. It is completely free to download, so free as in free beer. It is under the MIT license, so free as in freedom as well. It is not a true open source software in that they don't release data about their training and things like that, so caveat emptor. Using Whisper is very easy. I'm not going to go over it right now. There's lots of great tutorials, but it can be run from a lot of different ways, including just running it in your browser. If you go to the Hugging Face space for Whisper, you should be able to run it with no other installation necessary. OpenAI released a bunch of default models. Here's a quick summary of them. Basically, the more parameters, the more accuracy, but it also takes a lot longer to run. But it's not just the regular Whisper OpenAI models. It's also, there are over 10,000 models that are tagged with Whisper if you just search for Whisper on Hugging Face. We don't have time to go through them all right now, but I did want to highlight a few of them. Just categorically speaking, some of them are all about making Whisper faster and just run faster. Some take a distilled approach, so they basically shake out all the parameters they don't need, so it runs with a much smaller core set of parameters. There's a few language-specific ones, but there's also this interesting series of timestamp variations of Whisper. So my favorite is this one called CRISPR Whisper, which is just lovely to say, but it focuses on including all of the pauses, stutters, false starts, things like that, all your ums and ahs, whereas most Whisper models are trained to ignore those. This one is specifically designed to give you word-level accuracy in your timestamps. Quick note about the scaling. We know that GPUs make it a lot faster. So here, this is the time it takes to transcribe something, so lower is better. So GPUs can give you over a 10 times speed up, but they also come with extra cost, not only the physical cost, but configuring it, keeping it running, and then the deprecation over time. It can also be run on a thing called a TPU, and if you're not familiar, a TPU is a tensor processing unit. And if you haven't taken your linear algebra class recently, basically it's just a matrix with an extra dimension attached. It's a lot like a GPU, but it takes a lot lower power consumption, and it can do really amazing things, especially with video identification, detection. There's some really interesting things. The actual chip itself is about the size of a micro SD card. I have one here that's put on a USB drive. This is made by Google Coral, and it's a fascinating piece of hardware. It can run Whisper through the JAX library, and it claims it's 70 times faster than the original Whisper PyTorch implementation. So that means you can do a half hour in about 10 seconds, or 150 times real time. But are we using any of these? No, because CPUs are free. We have CPUs at home, and they work. And it's still fast, even though it might be slow, it's still faster than doing it by hand or paying someone else to do it or using CalD or another model or waiting for something better to come along. So for us, that's good enough. The way we actually run it is through this Whisper bot. I'm not going to go over the specifics of it now, but here's a very brief flowchart. I'm not recommending you do it this way. I'm saying this is the way we do it, and it works for us. And, but basically it all works through S3 buckets, through a listing bucket to grab the list of things to do, and then a processing bucket for the rest of them. But even when it says done in this, we're not really done because we know we have a bunch of errors in these transcripts. So for that we use Fixit Plus, which is a library developed by the New York Public Library, I believe, and we run a server of it so you can access it. In our case, see if we can see if this works. You should be able to go to theamericanarchive.org and it'll take you to a, maybe not, anyway. Oh well. Well, it worked in rehearsal. Yeah, well, maybe if we have time at the end, we'll go over a little demonstration of that. Yeah, okay, encoding that. Oh, well. So Whisper's very great. It does a lot of languages, but not necessarily all of them. Does anyone recognize this particular language? Shout it out if you know it. Ubbi-dubbi, that is correct. So sometimes it's easier to just describe the words than to transcribe what's going on. So anyway, in closing, how many transcripts have we done with Whisper? Well, that red line is when Whisper was released, and you can see a pretty much straight rocket climb up ever since then. So in the last 2 or so years, we have doubled our number of transcripts that we had available. We had about 75,000 before, and now we have about 150,000. We were ingesting them at a rate of about 2,500 a year. That's now over 37,000 per year, so over a 10 times speed up. And like I said, we've transcribed everything in the online reading room, and we are working towards getting 100% transcription, and I would love to be able to tell you when we would reach that. Unfortunately, we are also ingesting about 30 or 40,000 items a year, so we have a backlog of about another 75,000 transcripts to go before we can get there. And then even when we get to 100%, we won't be done because these have all been transcribed with the base model. So we want to be able to have larger and more specialized models for certain things. Obviously, we want to reduce the hallucinations. We want to be able to better scale up our systems with the better hardware. Also, crowdsourcing the processing is another thing we'd love to be able to do, so people can volunteer their own computers, just like a study project or something, and we can use crowdsource resources. And then language identification. Whisper is very good at a lot of languages, but there are some languages it doesn't do very well. So we want to be able to identify those and group them together so that we can research them and have them available for the next generation of language models, so that low resource languages will have a better opportunity to have lots of good transcripts, because the transcripts really do make everything about our processes better. They make everything more discoverable. They, in addition to the closed captioning, and so we are working as hard as we can to get everything done as soon as possible. So thank you so much for your time. Oh yeah. If we have a moment here, so let's see if we can find that, figure out what's wrong. Here we go. So if you can go to the AmericanArchive.org and click on the Fix It Plus button. It'll take you to the site where you can just type in a bunch of stuff. And I picked out this clip for reasons that I think you'll see why in a moment.
This is a Zoom game called Buzz Fizz. Buzz Fizz. Like all other games, it has rules. But we're not going to tell you what the rules are. So, see if you can figure them out as we play Buzz Fizz.
1, 2, Fizz.
4.
Buzz. Fizz. 7,
8.
Fizz. Buzz.
11. Fizz.
13,
14.
Fizz Buzz.
16.
Yeah. If you didn't figure it out, I'm sure someone in the Slack channel will let you know.
This is what Ivy League universities you can get into with a 3.6.
Do we have any questions?
Yeah, I'm curious to what extent you've noticed problems with like hallucinations, like you said, where does it make up whole sentences, and are they offensive, and are your stakeholders upset about that?
Excellent question. Yes, we have looked into that. We have yet to find anything that's systematically problematic, if that makes any sense. As far as we can tell, the hallucinations are basically based on whatever the thing it just heard last. So if there's like lots of long silence chunk, you'll oftentimes you just get the last thing it heard, it'll just regurgitate that back at you. And there are options that you can do to make those less likely. That's stuff that we're definitely trying to explore, but we absolutely try to look over stuff for problematic things wherever we can. It's difficult at this scale, certainly, but if anyone finds something that's problematic, we will absolutely take it down and revise it.
Hi. Kay from Brandeis University. So I wonder what the model temperature configuration you used to generate the transcript. So and follow up, what if you had high enough temperature that can make the model pretty undeterministically behave, how would you cope with the different rounds of whisper on the same input data and get the different outputs?
Yeah, excellent question. We are using just all the base parameters through our Whisper bot, and you can see all the code available online here at here. That's where all the code is running. So we definitely would love to be able to specify more settings, especially for on a asset by asset level. If we know that a certain asset has a lot of, say, music or something, and we know we can tune our parameters to that. Certainly, if we know what language the asset is in advance, passing those kind of parameters definitely helps, we've found. And we're always looking for more systematic ways to approach such a large collection like this. Okay, thank you so much.
All right. So afternoon break is now. We have a little bit of extra time for it, but we will be back in here. We're going to get started right at 3:50, so 10 of 4. This is a great time to sign up for tomorrow's lightning talks or for tomorrow's breakout sessions. You'll find them on the wall near the registration desk.
Little while. Yeah. We decided we're just using this, not lapels anymore. I don't care. I just was curious.
You know, I just went with
What was it? Okay.
I guess so. It's worked out. It'd be a pretty good
I just have to not wander.
No, yeah. Although
I
I'm
do.
sure if we wanted to, we could.
No, it's okay, because then the camera will lose me too, right? If I literally go.
I guess they can. I saw a note in the Slack and it was like, thanks to the camera
I
operator.
saw, but I didn't know if that. Anyway, I was curious.
Yeah. Don't stray too far, I guess.
Okay, yeah. The ads is I do this, you know,
Yeah,
unconsciously.
Oh, yeah.
I'll try to.
And you should be able to handle that.
Oh yeah, I should grab my notes. That'd be a good idea. Ah.
right, 1 minute warning. 1 minute warning. Gonna get started in 1 minute. All right, welcome back from the break, everyone. We're going to kick things off with a 20-minute presentation from Mike.
All right. Microphone check. Sweet. Here. All right, well, hello, everyone. And as you continue to filter in, hello. This is a talk about productivity. But I'm not here to sell you on a productivity system or my favorite tool, nor am I here to offer a sharp critique of the industrial productivity complex. I am simply here to rescue us all from the existential paradoxes of modern work in 20 minutes or less. First, a few necessary caveats. I am a white guy with an abundance of self-confidence. I am the walking, talking antithesis of imposter syndrome. I have job security and lots of autonomy in the work I do and how I do it. All of this matters when it comes to my ability to defend my time. When I had different roles, the approaches I took and also my stress levels were very different. Most importantly, what works for me in the current time and place may or may not work for you. That's why, while I'll share some of the specifics that I found useful, the focus here is going to be more on general principles that you can apply to yourself, at least I hope. So as you've probably noticed, we are awash in productivity advice. It's the self-help craze of our hyper-capitalist era. Endless methods promise transformation, but if these systems work consistently, we'd all be effortlessly efficient by now. I've read far too many productivity books and tried countless task management tools, and I've come to the conclusion that they work about as well as fad diets. They can help in the short term, but it's damned hard for most people to stick to one long term. At the start, you set up your perfect task manager, right? You carefully tag every task and you spend hours processing your backlog, and for a few weeks you might feel unstoppable. But then reality hits. You don't keep up with things for a few days and everything falls apart. One possible explanation for this? Well, as Meredith Farkas pointed out last year on her blog, Information Wants to Be Free, many systems assume a level of control over your time that simply don't exist for most workers. They rarely account for caregiving responsibilities, hourly jobs or service roles, realities where just time block your deep work isn't an option. Many productivity books are written by researchers or full-time authors, people who, by definition, don't face the same constraints as the rest of us. So take all of the following with very large grains of salt. One of those professional authors, Oliver Burkeman, actually makes a valuable point about this. You can't adopt anyone else's system wholesale. You must adapt it and make it your own. And James Clear in Atomic Habits says lasting habits aren't built from willpower, but from systems that align with human nature. Here's another way of putting it. No system can survive contact with your lived reality. You'll inevitably start to ignore the parts that chafe or revert to habits that suit you better. That's why I'm not giving you a system. Instead, I'm going to try here to give you building blocks I found, pieces that you can mix and match and refine over time to fit your personality and the situation that you find yourself in. So here's what I found. Across systems like Getting Things Done, Slow Productivity, Personal Kanban, and others, 5 steps consistently appear. Capture, prioritize, plan, focus, and reflect. Take those in order very quickly. David Allen's Getting Things Done emphasizes that your brain is a terrible task manager. It wasn't designed to track everything you need to do at the right time in the right context. So the first building block, capture, means getting every task or idea quickly out of your head and into a trusted system, so you don't lose track of important things, and so your brain isn't stuck trying to juggle them all. Holding open loops in your mind doesn't just risk forgetting things, it overloads your cognitive bandwidth, creating stress and continual distraction. In general, it's important for your capture process to be as frictionless as possible. When something pops into your head, you want to jot it down before you lose it and then get back to whatever else you were doing with minimal interruption. Prioritize next. Prioritization isn't just about ranking tasks, it's about making decisions. Keeping up with what's urgent is hard enough, right? Somehow you have to also make progress on what's important. When urgency and importance overlap, your priority is obvious. But the real challenge is minimizing the time you give to the urgent but not important, which will consume your entire day if you let it. And while it's very hard to carve out time for it, some of the biggest wins come from accomplishing the important but not urgent, right? So focusing on that quadrant. Urgency and importance also change over time. So as deadlines get closer or the facts on the ground shift, things that were urgent you don't get to, turns out not that urgent in the end. That's why prioritization isn't a one-time decision. It's a constant process of reevaluating what actually matters. And what is it that matters? Well, Mark Manson puts it bluntly in The Subtle Art of Not Giving a Fuck. Who you are is defined by what you're willing to struggle for. So your work, your projects, your commitments, they aren't just the things you get through. They define you. Right? Productivity isn't about just doing everything. It's about deciding which struggles are worth your time and letting go of the rest. That's the hardest part of prioritization, making peace with all that won't happen. But deciding what happens isn't enough. You still have to carve out time for it, and that's where planning comes in. Planning is how you turn priorities into action. Planning connects what you want to do with when and how you'll actually do it. The best planning happens at multiple time scales. So you start with, maybe you don't start with, but you have long-term plans like yearly themes or quarterly goals, and those give you direction, keep you pointed at the important things. Monthly and weekly planning at that kind of medium time scale translates the direction you want to go into attainable goals for given time periods. And daily planning turns those goals into actionable tasks, ensuring you're consistently working on what matters most. If you don't take the time to plan your work, your to-do list is just a wish list. If your task management and your time management don't align, then your priorities are always going to get pushed aside. So you need a system that connects what you plan to do with the actual time you have. And maximizing that time is all about focus. Focus is needed at both macro and micro scales. So, because it's about protecting your attention, but also limiting work in progress. And those two kind of work hand in hand. The biggest productivity gains don't come from working faster, but from reducing how many tasks, projects, and responsibilities you are managing at once. More projects in motion mean more costly context switching, more time spent on coordination, and less actual progress. The most effective systems help you limit active work in a given time period. But focus isn't just about limiting what's on your plate. It's also about making sure your time is actually protected for deep work. A well-planned day won't matter if your time gets chipped away by meetings, constant interruptions, last-minute requests. And Cal Newport in Deep Work emphasizes that long, uninterrupted periods of focus are essential for meaningful work. But you have to work to create the focus. If you don't control your calendar and set boundaries, carve out deep work time, you'll find it's difficult to make progress on the most difficult but most valuable parts of your work. It might take pretty radical action on your part to consistently protect blocks of uninterrupted time, honestly. You may have to get ruthless at defensive calendaring or renegotiate meeting schedules, or you may even have to let go of some projects or responsibilities that you really want to do. They're not imposed on you, just choices you're making about things that you want to do, but you have to let them go to get your workload under control. It is worth it, though. Finding flow while working on things that matter is the best recipe for accomplishing important things, and it's mentally rewarding. It's well worth making some trade-offs for if you are all able to do so. Lastly, reflect is about feedback and iteration. Regular reflection forces you to compare your plans to reality, ensuring you're not just going through the motions, but actually improving how you manage your time and attention. A quick daily review helps you close the loop on what gets done, or what got done, and what's next, so you can reset for tomorrow without loose ends. A weekly review zooms out. Did you follow through on those plans? If not, what took up your time instead? It's also a chance to process your capture list and declutter your desktop. Bigger picture reflection, monthly, quarterly, yearly, that helps you spot patterns and adjust your priorities, make sure your work is still aligned with what matters. Reflection also helps you distinguish effort from progress. Reading about productivity instead of doing the work, or tackling low-value tasks like clearing out every last email from your inbox, those things can feel productive, but don't necessarily actually move the needle on your work. It's easy to fall into these time sinks. Pausing to reflect keeps your system working for you, not the other way around. A flawed system looks great on paper, but falls apart in practice. You capture everything, but you never review your to-do list. You set priorities, but you don't protect time for them. A good system makes sure each step reinforces the next, so that the work that matters actually gets done. Now, these are the fundamental concepts of any effective system, but every one of these building blocks exists on its own spectrum of structure. Some people love rigid systems, strict time blocking, detailed workflows, meticulously categorized tasks. I am not one of these people. That's what works best for some people, though. Others need a looser approach, just a rough list and broad goals, for instance. There's no universal best practice. You can have kind of a spectrum of what works that's very customized for you, as long as you're still catching all these building blocks. So take capture, for example. You could have high capture or low structured capture. You might create items directly in your task management tool, tag them, categorize them, or you may find it's best to dump everything into a running notes doc and process it later. Planning could mean scheduling your entire day down to the hour and minute, or just choosing one or two key priorities and letting the rest fill in naturally. Oh, I went a little fast, but that's okay. You need all these concepts in a complete system, but the level of structure is up to you. The sweet spot is the least structure you need to stay functional. Too little, things fall apart. Too much, you'll spend more time maintaining your system than actually doing the work. The best system isn't the most intricate one, it's the one you actually stick with. So keep it simple. That's where I was supposed to advance to this slide. A common mistake is trying to fix everything at once. Too much change too fast is just going to overload you. So I suggest trying to add one change to your routine at a time and monitor what the results are. Do that reflection step. And once you've accumulated all these building blocks into a complete system and lived with it for a while, over time you're going to want to start to pare back things as well, things that aren't adding value or adding more overhead than the value you're getting out of them. Because a great system, I think, gets easier to maintain over time, not harder. You get used to it, you'll get in the flow of it, and spend less time on the kind of administrative parts. Personally, I find it best these days, I just set one work goal and one personal goal a day, which took a radical step on my part of just accepting, not that I'm not going to do anything else, but these are the two things I am going to get done, and figuring out kind of how to scale those. So those things are kind of like anchors that I'm committing myself to getting done, even if my day gets completely eaten up, my focus is shattered. I can throw everything else overboard, but if I keep my eyes on those and just get two simple, basic things, I'm still moving the ball forward, right? And it's kind of amazing how things will stack up if every day, if every week you're getting 5 things done, it adds up a lot better than when you have those 0 accomplishment days, when you're just chewing through emails in meetings all day and you're not making any progress on bigger goals. And if I do finish them early, if I knock out those 2 tasks early in the day, that's a good problem to have. I just pivot to whatever's next on my task list, or maybe even feel like I have time to nibble at something that's important but not urgent, but has been lurking in the background. Even the simplest system won't hold up, though, when things spiral completely out of control. Maybe you're drowning in deadlines, or sick or recovering from illness, or perhaps spending every available minute of the past week preparing your Code4Lib presentation. When that happens, you're not going to want to keep up with your usual structure, or you're not able to keep up with that structure, but you'll also want to prevent total collapse and losing track altogether and having to kind of start over from nothing. For me, the absolute minimum is just making sure I'm staying at least a day ahead on my calendar so that I'm prepared for the next day, or especially if there's something I need to do today to be ready for tomorrow. The other thing I do is just, instead of doing clean kind of capture and planning, I'm just literally dumping everything into a bulleted list in a Google Doc. And anything that's time sensitive is going to get moved to the top, put in bold with a due date on it. That is not a good system, but it is a workable, minimal system for the stressful times, which sometimes is not a day, sometimes is weeks or a semester at a time. It just depends on what the load is. Those are my personal fallbacks, but you're going to want to figure out for yourself in advance. When times get tough, this is my minimal viable system for productivity, that I can still trust that the most critical things are getting attention and they're not occupying loops in my head over and over again that I'm stewing on them, worrying about them. Putting them in something I trust, looking at that thing regularly, and getting on my way. A core principle of getting things done, this is intentionally blank, by the way, is that you can only work on one thing at a time. You can't actually work on a project in a meaningful way. You can only work on a single task that's part of a project at any moment. You stack those up one after another, and at the end of the sequence of those singular tasks, project's done. The same concept actually applies to everything, if you'll allow for a bit of metaphysical detour here. Think of yourself as a series of U's, not the letter U, Y-O-U. Past, present, and future, each one living in their own present moment. So observe this image from the second best Star Wars movie in existence. Demonstrating a version of this idea. Like Ray here, you exist at the end of a chain of past yous, past moments that you have lived through, and at the start of a chain of future yous, always extending slightly ahead of you. Past you is why you're in this mess. They procrastinated. They got distracted. More than anything, they left you all this shit to do. And future you, they're a slacker, right? You make simple, reasonable plans. I should be able to get that done in 2 weeks. I need to focus on this project tomorrow. But when they're actually up to bat, future you, they fuck it all up. The important thing here is that present you is the only one who actually exists, and therefore the only one who does any work. That work you did in the past is all sunk cost. The work you'll do in the future, that's a probability field. It hasn't collapsed into reality yet. It may or may not occur. So now is the moment that matters. Many nows, over and over again. What you choose to spend your moments on is the only way you can affect future moments for good or ill. And the truth is, you are probably setting future you up to fail. You committed to more projects than future you actually has time for. You underestimated how long future you would need to fix that bug. You forgot about that deadline that's going to screw up future you's plans for next week. The kindest thing you can do for future you is to stop making their life miserable. One of the best ways to do that is get shit done. And it starts with starting, actually. Most people assume motivation comes first, that once they feel inspired, they'll finally get to work. But to quote The Subtle Art of Not Giving a Fuck again, action isn't just the effect of motivation, it's also the cause of it. This is what Manson calls the do something principle. If you're stuck, don't wait to feel ready. Just take the smallest possible step. Open that doc and write the first sentence. Open up your code base and start writing, because you're going to engage with the problem that. The act of doing creates momentum. Momentum fuels motivation. The moment you engage, your brain shifts gears. You're no longer thinking about doing the thing or finding increasingly ways to not think about doing the thing. You're actually doing it, and your brain will shift into that problem-solving mode, which feels a lot better, and it'll start to grapple with how to get to the second sentence and the third sentence. That's why the best systems remove friction from starting. They don't wait for motivation, they make action the default. The easier you make it to begin your tasks, and the more you practice engaging over avoiding, the less likely future you is to be buried under past you's unfinished plans. And yet, even if you do everything right, even if you set future you up for success, there is one more hard truth. Work is infinite, and you are not. We like to imagine that if we got a little more efficient, we'd finally get ahead of our never-ending flood of obligations. But that day will never come. The better you get at your job, the more people recognize you can handle things, and the more they're going to send your way. Oliver Burkeman calls this the efficiency trap. The faster you work, the more tasks arrive. If your only strategy is to work harder, you're just accelerating this same cycle, never actually getting ahead. So what's the alternative? Accept that you will never finish everything. The goal isn't to get it all done and get to the supposed end of the list. It's to choose what's actually worth doing and let go of the rest. This is where the subtle art of not giving a fuck comes in once more. Manson puts it very bluntly. The key to a good life is not giving a fuck about more. It's giving a fuck about less. Giving a fuck only about what is true and immediate and important. Productivity isn't about getting everything done. It's about choosing which struggles are worth your limited time and energy. Berkman offers a helpful mindset shift for this. Instead of treating your task list like a bucket you need to empty, treat it like a river you dip into. If you treat your tasks like a bucket, you're setting yourself up to feel constantly behind. A river, though, keeps flowing regardless of what you do, so you take what's valuable while letting the rest move on. Not everything will get done, and that's fine. You'll never clear that backlog, and that shouldn't be the goal. The goal is to choose what matters and fuck the rest. Thank you, everyone.
Awesome. We have time for a question.
Thanks. I like I like the perspective. It struck me that it was most useful for someone who's working mostly by themselves. And so then I was trying to think, when you've got a team or a manager, for which parts of what you outlined do the team and the manager either help you or hold you back? Like I was thinking in particular, if you've got a really good team or a really good manager, then the reflection part can be really assisted by their input. But I was thinking for some of the other parts, sometimes having those external people can get in the way or just cause, have new inputs to your workflow that you don't really need if you're trying to get things done. So any thoughts on that?
I would say when you're working with a team, there is a lot more overhead to every project and every task, right? There are a lot more coordination costs with the more people who are involved and the more stakeholders you have. Sorry, I might have stepped away from the mic here. But I do work with a team. I manage a team. I have a good manager. I have a great team under me. I would say I try to bring these same approaches to our own planning and focus and prioritization. So I work very hard to limit the work we have in progress. So we have a very, very long infinite backlog, but a very tight and short active lane that we are pushing stuff back out of when new stuff comes on, so that that list is not allowed to sprawl, right? And that often means telling people who were waiting on something we were working on, that's now not happening, right? That's gotten pushed out by a new priority. But I think transparency is the most important piece about that. And people, customers, stakeholders, internal stakeholders, peers, will give you a lot of leeway if you are upfront and if you deliver on what you promise, or acknowledge when you're not going to be able to. It's more when it goes into a black box and and they don't know what the status is, that there's a lot less forbearance for this kind of rigorous focus. Anyway, I think I probably ran over my time in my answer. Thanks, everybody.
All right, good afternoon. I'm Brandon Patterson. I'm a technology engagement librarian at the Eccles Health Sciences Library at the University of Utah. What that means is not only do I work with some of the software that we have, but also the hardware in the library. And today I'm presenting on a preservation project I did with my colleague Matthew here. So I'm going to be talking about a technique called Gaussian splatting, and my colleague Matthew will be presenting on photogrammetry, which is a similar but different technique. And this is our first time presenting at Code4Lib. So thanks for having us. So we will discuss these techniques using a case study with a touch of intrigue and dabble in the mysterious, using terms like Gaussian splats and fiducial markers. The problem we are trying to solve is preserving not only a single object, but an entire room or several rooms. The title slide here shows one of our prototype scans of where else but a room near and dear to our hearts, a technology closet or tech closet. If this were the board game Clue, you wouldn't be seeing Colonel Mustard with a pipe, but us trying to figure out how to 3D scan a room with knickknacks, loose wires, and the occasional half-eaten sandwich. The room we're trying to preserve is owned by this professor here. He's the professor of anatomy at Utah. His name's Dr. Edward Hashimoto. He's the School of Medicine's most tenured professor who taught for 50 years, retiring in 1985. He was known for his two-handed anatomical renderings, and his home is located just a few blocks from our campus. After his passing, his spouse and family left his home office and exam areas exactly as he left them, really being a time capsule for that period. And heirs and campus historians wanted us to capture that, so that's what we did. Our initial experiments had us using this technique called Gaussian splatting. We use an application that's free to use called Scaniverse, and we wanted to try this to see if we could render those 3D objects in that room. So the way Gaussian splatting works, it's a rendering technique for real-time 3D reconstruction and rendering of images taken from multiple views. A 3D space is defined as a set of Gaussians, and each Gaussian's parameters are calculated by machine learning. Named after Carl Friedrich Gauss, a German mathematician who pioneered the concept in the 1800s, the technique, in simplistic terms, creates millions of fuzzy floating balls in space and colors them so that the edges represent volume. And you can see that there with the rendering of the statue. So here's just us playing around with the Scaniverse application. Again, this is something anyone can use on their phones. It turns out that splats look more realistic because they do a better job of adapting to features like lighting based on different viewing positions. So we took this technique and applied it to some objects. You could see that these close-up objects using the Gaussian splats did do a substantial job. Usually these match the quality of high-end scanners that we had, like the Arctec EVA, even on objects with fine print. So you can see the comparison here between the two. Rendered 3D objects were then sent to our digital collections team that deposits scans in a customized search platform built using Solar Falcon. And so our early versions of this, unfortunately, had, with this larger space, using this technique, had some created ghost objects and large gaps within the room. Our team wanted to also see if we could build this in a VR environment so folks could walk through it as if they were there. And we tried this and found that overall it left viewers a bit disoriented because of those holes and gaps that the Gaussian splats did create. So now Matthew's going to talk about our next step, which was using photogrammetry to capture this.
Hi there, I'm Matthew Elliott. I'm a 3D design engineer at the University of Utah. I was in charge of our kind of second attempt at documenting all this. I used more traditional photogrammetry. The reason I did that is it's a really low-cost solution for 3D scanning. You just need a camera and some free software. Before I get too far ahead of myself, let me just the quick and dirty of what photogrammetry is. So basically, you're using 2D photographic images to get details about the 3D environment. You are essentially taking two images that have a known relative position and then finding a common point in them, and it's a bunch of trigonometry. I'm not going to go into the math. There's a really interesting research paper you guys might like. We have a link at the end. It's a lot of linear algebra, so you computer science people may find it enjoyable. Well, you might. It's older technique than you might think. He was an engineer in the French army, Ami Lusadat, pardon my French. Surprise, surprise, though, this technique comes from defense spending. Like so many amazing inventions, they have their roots in a little bit of evil. This is one of the first practical applications of photogrammetry that they did. They took these 8 photographs from around the village of Buck, and then they used those to create this like detailed map of the town. I just think it's pretty interesting. You think of these like computer vision techniques and all that, but really it started pen and paper a long, long time ago. So this is Dr. Hashimoto's waiting room. This is a 3D rendering that I created in Reality Capture. So this is actually like the data that we've gathered. This is part of one of the scans. Reality Capture is a free software from Epic Games. They do Unreal Engine and Fortnite, you might know. But they do a lot of other stuff too. So Unreal Engine is one of their products. These thumbnails that are all throughout the scene show the positions where I took images from. This kind of gives you a sense of how labor intensive this process can be. I ended up taking over 2,000 images. It was 500 gigabytes of data. It took over 2 days. Bring a lot of memory cards. It will save your life. So then this is from his office. It's one of his tool cabinets. You might notice these little QR code looking squares throughout the scene. Those are the fiducial markers that were mentioned. This specific kind of them is called April tags. They were created by the April Robotics Laboratory at the University of Michigan. They're used for autonomous robotics, like in real time to help robots find locations in space and navigate. They're really cool. They can get like the distance relative to the camera and like 6 degrees of rotation. So it's not just like a single point. You get a lot more information about it. We have a quick video that I'm going to show of like one of the final renderings that we got just after another image showing these camera positions and how they relate to that fiducial marker. But like I said, I have this quick video of the final rendering, just like a motion sickness warning. It is like a camera moving through the space, so if that's a concern for you. Awesome. Okay, so we have the exterior of his house here. It was just right up on the sidewalk. You know, you just walk right off the street and down into the basement here. You can see we had some trouble capturing the front door. Anything clear or reflective is a real nightmare for photogrammetry. This is a more detailed view of his waiting room. Again, you can see there's a mirror in the corner over there that's kind of a void into nothing. Not a lot you can do about that as far as I know with photogrammetry. Next, we're going to go over into his office where he actually like saw patients and sat down with them. You can see the kind of the detail you can get of the tiny objects on the desk here. And then we'll go up closer to that tool cabinet that I was talking about. He was not an organized man. That's what I can say for him. He was also very fond of knickknacks. He had all these little statues and things throughout his office. I probably only captured about 1/3 of them in this rendering just because it's pretty overwhelming. There's just a lot of this kind of stuff around his office. And then our last view here is going to be one of the exam rooms where he saw patients. It's really neat. I think it's kind of like in the exact condition that he used it in. You can see his code on the wall there, and some more examples of those fiducial markers in the scene. Those are invaluable in aligning the images. We are actually leading one of the post-conference workshops where we're going to go through these techniques and like walk you through doing a scan. So those of you who will be there for that, look forward to it. Awesome. Yeah, thank you so much, everyone.
That was wonderful. No time for questions, unfortunately. We'll bring up Owen.
Oh, well, I'm just going to open it. Well. Hi, everyone. I'm Owen King. I work at GBH Archives, the same place that my colleague Harpo works at. And I'm presenting today with my colleagues at Brandeis University in the Computer Science Department, Kyungmin Rim and Mark Verhagen. And we're going to talk to you about cataloging video via computer vision. So the context of this work and its use case is in the American Archive of Public Broadcasting, which is, again, the project that Harpo was talking about. It's a collaboration between the U.S. Library of Congress and GBH to coordinate a national effort to preserve and make accessible historically significant public radio and television programming from the last 70+ years. Now, the reason this is important is that we take in a lot of video cassettes. So it might work like this. We reach out to a public media station from some city in the US and we say, hey, we think you ran a show in the 90s. Turns out they have 1,000 tapes of it. We take them in, we digitize them, and then we have those digital files and we need to catalog them. All we have sometimes is what was written on the boxes, which might be just a series title, an episode number, and a date. And that's not very good metadata for powering search. So that sort of brings us to our problem statement here. So imagine for a moment that you're a librarian tasked with cataloging a huge stack of new books. And imagine that most of these books has no cover, no table of contents, and no index. Now apply that to video. That's what our cataloging team faces on a regular basis. So our solution is to have computers watch videos to assist the catalogers. The insight was that particular frames from video, particular frames with text, the scenes with text, have information that can really inform what metadata we put into the catalog. So our thought is, can we take those scenes with text and create metadata from them? You see some of the scenes with text up here that are relevant. The program slate in the top right, a chyron or lower third, the middle one, or credit sequences, which we all know from television. So our eventual ambition is to extract the data from these scenes with text and make it available to catalogers to review, to put in the catalog. But our first step was simply to identify the scenes with text and make them available to catalogers at the time when they're doing the cataloging so they can quickly use this for cataloging. You could sort of do this just by watching the videos, but when you jump through a video, you miss these things because that chyron that identifies the person, that might be on the screen for all of 10 seconds in a 60-minute video. Very easy to miss. So to give you a little idea, here are some of the scenes with text that we're trying to find in our videos. And what we're going to try to do is have an image classifier identify these things. Now, as most of you probably know, computer vision's come a very great distance in the last 10 or 15, 20 years for image classification. But image classification is especially good at telling you what objects are in images. It isn't very good at telling you the difference between a chyron and a credit sequence. In other words, most of these image recognition systems weren't trained on this kind of data. So the first thing we had to do to get this project rolling was create a bunch of data ourselves. And so for this, we created custom software for labeling data, something we call the keystroke labeler. And this allows you to classify still images, which we've extracted from videos, with just a single keyboard press on the computer. Originally, we thought we needed at least 10,000 images in order to have any hope of training a computer vision system to be sensitive to the kinds of categories we're interested in. But once we got rolling with the keystroke labeler, we created a lot of data, so about 70,000 images so far. And with that data, we started creating an application that could use that data to help with cataloging. So on that note, let me hand it over to Mark.
So how do we get to those data? We have these images, and we have a... Too far away? Okay. How about this? So we have this procedure, and we start, step one is actually to go to the individual images. We extract the frames from the videos, typically 1 per second, maybe 1 per 2 seconds, maybe 1 per half a second, and then we classify them using a neural network that Kay will explain more about a little bit later. Our second step is to take these point-wise observations and turn them into information about time frames, because we want to get the time frames. The time frames are sort of the basic building block here. We want to know this is where the slate is. We want to know this is where the end credits are. So when we have that, we can actually go in there and try to find a particular kind of metadata we want to find there. Where are the juicy morsels of metadata that we want to find? Now, when we have that, we can wrap this up in a nice visualization and throw it over the fence to the archivist. And the archivist can look at the visualization and say, okay, that's where the director is mentioned, and this is what's interesting in the say the credits or in the chyrons. This person was in this video. I can make note of that, and in reality, this does speed up their workflow having this information available. Now, we might add some bell and whistles to it, right? This presentation is about just these time frames, but you could imagine that we take those time frames and say, okay, we do OCR, here's the text, then we do some language processing on the text, we find out, oh, director is mentioned, some name is mentioned, that must be the director, there's a date here, it could be the creation date or the broadcast date. So when we have that, we can all add that to that visualization. Now, I'm going to hand it over to Kay in a little bit to talk about details, but at the background for us at Brandeis is the CLAMPS project. And I just want to say a few words about CLAMPS. CLAMS is nothing more or less than a way of dealing with different kinds of processing modules that process different kind of modalities. Right? We are dealing here with text, we're dealing with audio streams, we're dealing with images, we're dealing with videos. And we're dealing with, also in some of our workflows, we're dealing with all those things together. Right? So we built CLAMS as a way to seamlessly integrate them. So we can have one process that gets us, say, the time frames, and another to pull out the text, and yet another to do the language processing. And this is all held together by this format called MIF, pronounced MIF or MIF or MIF. It's a JSON LD format, mostly JSON, a little bit of LD thrown in for linked data. And it acknowledges that we have three kinds of annotations, one over characters, one over regions, and one over streams, like audio or video. And they are all represented the same way, right? There's a type, there is the anchoring properties, like start and end, which might be coordinates on an image, and then any kind of other information that we want to express. So, in addition to that, we have ways of linking this information so that we can express, okay, we found the name of Bill Clinton at this piece of text, and that piece of text was actually this bounding box at this location in the video, and that we can all express. So I can talk 10 more minutes about this, but I think it's time for Kay to show how we did some of those earlier steps in the process.
So this is CLAMS, and what we are presenting today is just one application that we deploy on the CLAMS that we call SWT detection, and this is as Mark already mentioned, that we built two-step process for this scene with the text detection. So one is image classification to find out where the texts were seen on screen. And the second step is the what we call stitching of those points into the time frame annotation. So for image classification, this is fairly standard, I think. Computer vision image classification implementation using some pre-trained large CNN model to get the image vector and then pass it to, in our case, it's simple, straightforward multi-layer perceptron neural net to get the probabilities of each labels given this image. And what we did a little bit different is that we added this additional positional encoding that that encodes the location, namely the timestamp of the image was extracted to the vector. So our rationale was that we already know that some kind of images are only occurs either at the very beginning of the video or at the very end of the video. For example, slates usually happen very first thing, and credits are usually happen toward the end of an episode or edited video. So that's why we did two feature extraction, one from the pre-trained CNN network, and second is position encoding, and then pass to the classification model. The second part is the stitching of those point-wise classification. So if you look at the figure here, the top part of the figure is based, you can think of it as a point-wise annotation that came from the image classification results. And some points are empty because we were just too lazy to fill those in. Imagine that given you pass those images that evenly extracted from the video, the classifier will return all the labels to all these images. But sometimes we see noises or misclassification results, like red points here. And so by stitching all those image classification results into a larger unit, like time unit, we actually see the decrease in the noise or misclassification decreased. And second, because we passing images that is already sampled, we are filling the gap between those sample rates with the particular labels after this. This is a Stitcher implementation, so this is simple mathematical morphology algorithm to that very basic technology used in computer vision. We just apply that to a one-dimensional, in this case, line data to remove the noises and run through the moving average to get useful labels out of it. And to test our lab, this is a machine learning application, so there's no unit test to test. So we actually leave some holdout set from the annotation data as a test set, and we ran a statistical testing of counting what was the right, what was the wrong, and how much of false negative and how much was false positive was. Given all of that details, I'll give it back to Owen.
Great, thanks. So once we have the SWT app, what that does is it looks at a video and outputs this MIF or JSON format, which tells us where the scenes with text are. But a JSON file is not especially useful to a cataloger. So what we need to do then is have something that takes the JSON file and then does some post-processing, going back to the original video and pulling out exemplars of the scenes with text and putting them in a handy format. So this is what we call a visual index or a visaid. So as of last summer, every new item coming into the AAPB gets a visaid made for it. We've made over 13,000 of these so far. And you can sort of see from the visual here, I think, how this visaid information would be useful at cataloging time, especially if prior to this you didn't know much about what was in this video. So just last week, we broke out this software from our software stack and put it in a Docker image for other people to run. So you can just pull this Docker image and run it, and you can make visaids like this for your own collections, if you have any. When you run it, you'll get some ugly output. Depending on what kind of computer you have, it may take a while to run. It can be 5 minutes for an hour video if you have a GPU, maybe 3 or 4 times that if you have only a CPU. But I think that is it. The slides that are in the repository have links to the project and ways that you can try it out. We're very interested to have people try it out and let us know their experience of it. File a GitHub issue if you try it out and it doesn't work, or just get in touch with us and we'll have a Zoom meeting with you and figure out how to get this working for you. I think that's all we've got.
Thank you all so much. Unfortunately, no time for questions. We're going to get started with Charlotte. Thank you very much.
Hi, I'm Charlotte Kostelic. I am going to present on a Python library that I built called Pydantic Mark. My presentation's changed a little bit since I submitted my proposal, but the package that I'm presenting on is, it allows you to validate Mark records against, it allows you to validate data against Mark 21 rules in Python. So my goal was to enable you to validate Mark data without having to leave Python to, use MarkEdit, for example. I'm gonna get in the weeds a little bit with Mark data, and I know it's the second to last presentation of the day. I'm sorry, but that's what happens. Two computers. So I'm the metadata manager at BookOps, I work in the cataloging department. We are a shared technical services organization. And a partnership between Brooklyn Public Library and New York Public Library. I develop and maintain software for the cataloging department to help with our metadata woes. My cats are sharing, like the libraries. One of our metadata woes is dealing with vendor records that are full of errors. Sometimes the exact same error in every record, in every file that they send us. So last year I developed a tool, it's internal, to help us identify errors in order data in vendor records. After I created that, I was thinking, is there a way to make this more broadly usable to other people? And I thought it'd be kind of straightforward to expand it to validate against the MARC standard, and submit a proposal. So that's how I ended up doing this. So Pydantic MARC, you can install it with pip. You can validate your MARC records against the MARC format for bibliographic data. It's meant to work well with PyMarc, so you can pass a PyMarc record object to the Pydantic MARC record model, and it'll validate your data for you. If it does not conform to the MARC standard, it'll wrap up all of your records errors into some error messages that should be pretty familiar if you use MARC edit. So, for example, you can't repeat an 001 field. You have to have a 245 field, the title. And so it'll wrap it all up into one validation error. The tool is a library, so you install it, use it in your own code, and it's built using a few different scaffolding tools. PyMarc isn't technically a dependency, but the way that I built this, it expects you to be using PyMarc, because if you're working with MARC data in Python, you're probably using PyMarc. Your data should probably be structured in a way that PyMarc would also be able to parse it. It was important for me to make sure that this works with other tools. Pydantic is the only actual dependency. It's one of the most popular data validation libraries in Python. It's extremely fast, it's very customizable, extensible, and I'm going to explain how it actually works on the next slide. And then I used the MARC edit rules, the MARC rules file from MARC edit to create the rules that are in Pydantic MARC. So it validates each component of a MARC record, and they're all nested under a MARC record model. I'll explain what this means a little bit more. But essentially, it will check that every part of your record validates against the rules for that field. So what does it actually look like? Sorry. This is the data field model, and it's defined as a Pydantic model. So Pydantic, the primary way to validate your data is to define a model. So it inherits from this base model class, which is in line 1. And it looks, the way you define a Pydantic model looks a lot like a data class. So you define the different attributes of your object, and like a data field in PyMarc, a data field in Pydantic MARC has a tag, it has indicators, and it has subfields. It also has a set of rules, which come from the MARC edit rules file, and I'll explain it on the next slide what the rules actually look like. And Pydantic also is reliant on type annotations. So it expects your data to be a certain type, and it validates that it is that type. So the tag, for example, your tag in a MARC record, it has to be a string, it has to be 3 characters long, it has to be digits, and a data field has to be 010 or higher, basically. I'm sorry, I keep doing that. So this is it's a more complex of constraining your type than if you were just creating a normal data class. So as you'll see in line 11, there's a regex for your tag. And then also for the indicators and subfields, they are both they both have annotations for after validators. So basically, these are other functions that validate that these objects conform to the rules for these attributes. That's in addition to validating them against the pydantic indicators object. So mark rules are basically a list of whether or not the field is repeatable, whether it's required. If it's a control field, the length that it has to be, a list of valid indicators, a list of valid subfields, repeatable subfields, non-repeatable subfields. And this is just a tiny, tiny snippet of over 200 mark rules. So every field that's defined in mark, it has a rule in here. Anything that isn't defined in mark will not be validated against a set of rules. It'll just be validated as structurally a data field or a control field. And as I mentioned, Pydantic allows you to add additional custom validators. So first it validates that the indicators of a data field are single digit characters. And then it validates that they match the specific values for that field. So that's what it's doing here. It is also creating custom errors for each type, so that allows us to get the error messages that more closely resemble mark edit rather than Pydantic's error messages. And as I mentioned, there's one main model, and there are all these other models nested underneath it. So the mark record model is the one that you would probably actually be using. You'd be passing a chunk of data to this model and validating that it is a real mark record, it conforms to all the rules, and if not, it will give you errors. So the mark record also includes a leader. I cut out the extremely long regex from this so it would actually fit on this slide, but it will check that like all of the characters in the leader conform to the rules as defined in the leader field. And then fields, it's just a list of either control field or data field objects, depending on what the tag is that it's passed. So this union with annotated in lines 20, 21, and 22, that's basically saying it's deciding whether or not a field is a control field or a data field, and then it's validating against that model. It also then has its own custom validator to check that it has all the required fields and no repeating fields that shouldn't be repeating, things like that. So this is what it looks like to actually validate a record. You can open a record with a mark reader using PyMark and then validate it, and if it has errors, it'll print the errors. Otherwise, it'll print it in as a dictionary, in JSON, whatever you want. So this is a valid record. And this is an invalid record. It's putting the errors out in JSON. So then you can take those and hopefully in the future I'll expand it so I can actually take the error messages and then edit the records and output the records as valid. But I don't have any time to talk about that, and I haven't done it yet.
Thank you. Please definitely bring your questions for our presenters from this block to Slack. And finally, I'll bring up Beck. Need help. No, I need help. Okay, sorry about that. Okay,
So I am Beck Davis, and I'm a first-time presenter. And I'm also an early career fellow here at Princeton University with the library. I'm also a member of the Lumbee tribe of North Carolina. And I want to tell you a tale of language metadata enhancement, indigenous tenacity, and decolonization. So please be aware that I am going to discuss some historical anti-indigenous colonial policies or government policies during the talk. Also, I'm having a lot of fun today because I'm a big metadata fan. Since I'm covering a lot of information in a short amount of time, I do have a table of contents on slide 3. I double-checked, my slides are in OSF. Okay, so I'd like to start by telling you about my beef with the MARC code list for languages, which I'll call MARC codes for short, because I'm going to say it a lot. And as you can see by my dog's bombastic side eye in this photo, that's about how I feel. But I have reasons. The MARC codes are limiting. Thousands of languages or dialects are either not present or exist only as part of collective codes in the MARC code list. Since the Library of Congress, and that's because the Library of Congress requires a significant body of literature to assign a MARC code to a language. So many languages won't get codes at all, in my opinion. This lack of direct representation in the code set reinforces a colonial bias against the languages of colonized people, especially those who may not have adopted a writing system before being subjected to language erasing colonial policies. Also, the languages in these collective codes may not be mutually intelligible. For example, the languages in the North American Indian Other Code, which is 43. They're in the same geographic area, but they're not mutually intelligible. By contrast, the Algonquin Other has languages within a language family, so those should be mutually intelligible. So within the MARC record, language metadata is found in the 546 field as free text containing the language names, and in the 041 field using a controlled code the controlled code set to represent the languages in the 546 field. The 546 field's content can be displayed in the catalog, but is only keyword searchable. However, the 041 field's value can be both displayed and indexed as a search facet. If a language is in a MARC collective code, we'll only see that collective name. This makes our catalogs inaccessible. For example, if a user is seeking an item containing the specific dialect of Western Abenaki, they have to use a keyword search to even find Abenaki, which is only present in the 546 field. They have to take extra steps to verify if that specific dialect is present. This is because Abenaki is in the collective code for Algonquin Other. So the search facet and displayed name from the 041 field will only show Algonquin Other. So what can be done about these limitations? We can supplement with other controlled language code sets. The team at the University of Hawaii at Manoa recognized these limitations with the MARC records within their own library's Pacific Islands collection. They began a project to enhance their existing language metadata by using the ISO 639-3 language code set, which I'll call ISO codes for short. This code set works well as a supplement to MARC codes because there are approximately 5,000 languages and dialects represented with their own individual codes. So this team went item by item over several years with an estimated 11,500 items receiving these ISO codes. They did propose for several Pacific languages to receive MARC codes, but they were denied due to a lack of written evidence. I highly recommend reading the article Making Pacific Languages Discoverable, which is also the title of the slide, for further details of their work. So, many libraries can't dedicate time and staff to a similar project for their collections. For instance, Princeton University Library catalogers are actively using ISO codes as they work, but to go back into our collections, that's a lot. It's pretty daunting. So it prompted a question of how could Princeton University Library automate how could we automate language metadata enhancement using Ruby scripts by transforming our existing metadata? So the library's metadata enterprise operations team was already using Ruby for metadata transformation when I joined in mid-2023. So as a result, I learned Ruby to write this script with the help of my team members. And I'm going to show you some important lines from the script, but you can also scan this QR code or go to bit.ly/add ISO to see the full file. So the ISO 639-3 language code mapping in this, shown on the left side, is in a tab delimited file, and we read it into a hash for later use. And to prevent duplicated ISO codes in the from being added to the record, we check for existing 041 fields containing proper formatting with the indicator and a subfield 2. If an 041 with that formatting already exists, we just skip the record. Since all of our codes would go in the the 041's subfield A, which is reserved for primary language of an item's content, we needed a filter to reduce false additions. So we used an array of terms and a regular expression tester, or regex, to test against the value of the 546 field. So if a specific term was present in the record, it was skipped. It was almost 100 terms that I recorded for that. And this is the workhorse of the script. It's a regular expression that matches between the 546 field value and the names and the name to code hash from earlier, the hash I showed you. And for each new match, the appropriate code was added to the new 041 field, which is appended to the record when no new matches were found. So we just did that for each record. We processed the entirety of Princeton's catalog in late 2023. That was almost 12 million records processed in just a few weeks, which is very fast compared to having done it by hand. Unfortunately, however, only just over 325,000 items got new 041s with ISO codes added. And most of those were for widely used languages, like English. It was mostly English. But just over 1,100 languages were added that did not have, either did not have a existing individual MARC code or exist as a part of a collective code. There were a few issues. Unfortunately, by ignoring terms to prevent those false primary languages, we greatly reduced the languages that we could have highlighted by adding new codes. And also, regular expressions don't work when spelling varies. And also, when dialects aren't fully named, such as Abenaki versus Western Abenaki, or yeah, so we missed I believe we missed a lot of languages because of this. However, with this limited success, we were allowed to go ahead and upload those updated records to OCLC. And it was noticed that the new 041 fields did not comply with guidelines for using ISO codes to complement MARC codes. So we couldn't find a way to reconcile how to programmatically add these codes and follow these guidelines. So we had to restore the records to their previous versions, and we would lose the local versions through syncing with OCLC. I understood the decision. I do support it. It just really sucks that I lost like months of work on my first big project. So while it would make sense to have just walked away from this project and give up, I continued to think over how it could work better. I wanted to explore adapting this to more directly aid catalogers rather than kind of do their work for them. So after conversations with some catalogers here at Princeton who really advocate for the use of ISO codes, I kind of wondered, exactly that. How can we make it easier for them to use the ISO codes? Since the original project ended, 2 adaptations have been worked on to answer that question. Myself and others at PUL believe it would be useful for catalogers to have a tool that reliably recommends suitable ISO codes for the catalogers to review. We began building a Rails application that would accept a file of MARC records and provide the ISO codes while using Solr to index to account for those spelling variations. Unfortunately, that project had to be placed on hold. Myself and the other primary individuals, this was a passion project. We got pulled away to more priority work. But I'm hoping that someone listening will decide that they want to do this work. But I also wanted a way for you all to try out this work yourselves. So I made a repository with a Ruby script that is similar to my original script, but it doesn't do any pre-filtering and it doesn't add any codes to the records. So you can test the script, you can improve it, and it has sample records for you there to use. But I want to get back to why this work of supplementing language metadata is important. The reason I've been using indigenous languages as my primary example is to highlight the ongoing fight of many indigenous North American people to preserve their languages in the face of government policies of assimilation. We can support this decolonization work through language metadata and improved language discoverability. As colonial institutions collect diverse language materials, we have a duty to record detailed metadata reflecting that diversity. Language specificity is necessary to support a diverse library catalog and diverse user needs. Excuse me, I'm sorry. Part of the work to preserve indigenous languages, it happens in the academic sphere as indigenous peoples and their allies study and develop bodies of work focused on these languages. Improving language discoverability supports their supports their work. And this supports language preservation and decolonization efforts. Because Indigenous people in the U.S. are less than 1% of the population, excuse me, I'm sorry, less than 1% of employees in libraries and also in IT, we can't do this by ourselves. We need non-Indigenous people to help us do this work as well. So please supplement your language metadata, whether you automatically or manually add ISO codes. And make sure that supplemented metadata is indexed so that it can be used as search facets and be displayed within your catalog. I want to thank Mark Zaleski from the Meta Enterprise Operations Team for his guidance and mentorship on this project, Sean Warren and Beth Sadler for their work on the Which ISO application, and all of my colleagues at Princeton University Library who helped me with this over the last 2 years. And I also want to thank you all, and I hope you'll consider the ways that you can automate the use of ISO 639-3 codes or supplement your language metadata. And if you have any questions, please email me or find me this week. I will almost definitely be at Bent Spoon tomorrow afternoon.
Thank you, Beck. Have another round of applause just for all of our presenters today. Right, it's time to wrap up our first day. Just have a couple announcements and can let you go. So first off, if you're giving a talk tomorrow morning, please arrive between 8 and 8:45 a.m. to load your presentation onto this podium computer. And don't forget the newcomer dinners are tonight. Be sure to check the sign-up document for any getting together plans that your dinner organizer might have posted. And I know there's still some spots available, so check that out if you haven't made dinner plans yet and you're interested. Also, if you're interested, there is a Code4Lib morning run scheduled for tomorrow morning. What is that? Walk, jog, or run on the scenic Delaware Canal towpath. It's an out and back flat course. All paces are welcome. Go half as far as you want to and then turn around. I know all the details are posted online as well. They're starting at the Alexander Road parking area, 7 a.m. So check that out on the activities page if you want more specifics about the meetup location. And then finally, please don't forget your badge and lanyard tomorrow morning. Put it somewhere handy tonight so you don't forget to grab it on your way out the door. Thanks, everyone.